So in this case, we need to consider our typical exam question again for our paper two, as we are preparing for our exams that are ahead of time. This is November 2023 exam paper two that we are going to look into. As you can see, guys, it was a 3-hour paper out of 150. So make sure that you go through instructions, your information, as you are given. This question paper had 11 questions, and we are given, if necessary, round off answers to 2 decimal places, unless stated otherwise. So make sure, guys, you read all the instructions that are given there. That is meant for you to read and understand as you are to answer your questions. So question number one, without wasting much of our time, we are given a small tuck shop displayed a record of daily sales in rands. This is a display for the past 2 months. 60 days, we are given the number of days, 60. Using the following histogram. So as the information was being presented, it was presented on a histogram. That is what we had. Frequency in days, the daily sales in rand. So as we can see, this is like the interval from 300 to 400, with the frequency corresponding on the frequency axis there, where we have the frequency in days. How many days are there? So counting these, we're going to see that this was corresponding, each box was representing a 1. Like this is a 0 there. Then we've got a 1. This is a 2. This is a 3. This is a 4. This is a 5. Until we get to 5. So you have to understand how that is presented. So each box represents a 1. So that is what we have there. We have to study that. So the question was, complete the following table. Use the table provided on answer sheet A. You were given an answer sheet where the table was given like this. So I'm just going to use this one. The table was just like this one. All right. So it is easier for us to first work with the frequencies, then talk of the cumulative frequencies. As we can see, this is an information used on a cumulative frequency curve where you talk of the cumulative frequency. So before we talk of that, let's talk of the frequencies, as we are given an example from 300 to 400. The frequency there is 4. Is it exactly what we see on our diagram? From 300 to 400, the frequency there is 4. This line corresponds exactly to 4. This is what we see. So you're supposed to maintain answer in the same manner. This table, fill in our table in the same manner. From 400 to 500, 400 to 500. What is the corresponding frequency in this bar that we are seeing? What is the corresponding frequency there? So this is on top here, corresponding to 11. So this is 10. One box going up, that is 11. So as we can see, this is corresponding to 11. Straight here in this, that is corresponding to 11. So that is your frequency. So there's 11. From 500 to 600, you do the same thing. 500 here to 600. All right. So let's go up. The 500 to 600 is this big bar that we have there. So let's correspond straight going up there. What is it that we have straight? So this is 20, 21, 22. So that was at 22. This is the frequency. Okay, that's at 22. Then 600 to 700. All right, from 600 up to 700 here. This is the bar that we see at the top. So what is the corresponding value? If you go with this straight with your ruler, you are going to see that is this a value, which is at, that's 11. Remember, this is 10, and that's 11. This is 12. So this is at what? At 13. So the value there was going to correspond at 13. You take the frequency as it is from 700 to 800, the same thing. 700 to 800. This is our bar here straight. It was supposed to be like this. Yes, straight in this. So that was supposed to be 5, 6, 7. So that's at 7. So the frequency there is 7. 800 to 900, which is the last part that we see here, 800 to 900. So if you take this straight, it was going to be like this straight corresponding here to 3. It was going to be at 3. All right. It was supposed to be at 3 straight with this line of 3, this one. It's supposed to be like this. All right. Straight with that one. So if you take it, or you can even go this side. All right. That's 0, 1, 2, 3. All right. So as you can see, it is corresponding at 3. You can simply take this side. It is the same thing. So the frequency there is 3. So it is easier for us to work with the frequencies first. Okay. So how do you obtain the cumulative frequency? Remember, the cumulative frequency, when you are to draw the cumulative frequency curve or the ogive, you add the frequencies starting with this one. This is the one that we see here, which is the 4. So you're starting from there. We add to the next one, which is the 11. All right, we have the answer that we are going to write here. So that is 4 plus 11, which is going to give us a 15. 15 plus the next one, that is the answer that we are going to write here. 15 plus 22, that was going to give us 37. 37 plus 13, which was going to give us 50. 50 plus 7, which was going to give us 57. 57 plus 3, which was going to give us a 60. Remember your cumulative frequency curve, as we had your graphs from your grade 10 cumulative frequency curve, you add the frequencies. So that was your table. 1.2, draw a cumulative frequency curve for the cells over the past 2 months. Within this period, over the past 2 months, we are already having the cumulative frequencies. Use the graph sheet provided on answer sheet B. So this is what you were having on answer sheet B. They gave us something like this, right? So you need to draw the cumulative frequency curve on this. So remember, the cumulative frequency curve is drawn using the upper classes and the cumulative frequencies you use on these class intervals that we are seeing here. We use the upper classes 400, 500, 600, 700, 800. These are the upper classes versus the cumulative frequency. This is what we need to draw our cumulative frequency curve, which is the ogive. And also, as we are to draw this curve, we are going to notice that the starting point 400 corresponds with 4, meaning to say our graph is not starting from the 0 point. So we are going to need this lower class to be one of the upper classes also, but having a cumulative frequency here of a 0. So that is, you are going to need an extra class from what you had before. From the classes that you had, you are going to need another one that was the lower class. You make it to be an upper class. Why making this one to be part of our graph? So that the graph is starting from the ground. The graph is supposed to start from the ground going up. Not to say your graph is starting from a certain point like this. It is supposed to start from the ground. So if you do not have a 0 on these numbers, unless if they give you that, they can give you a 0 there. If they give you that, you do not force that lower class to be an upper class. No. Here, because we do not have a 0, so the graph was going to be like this. All right, I want you to see, remember we said upper class versus what? Cumulative frequency. So it's 400 versus a 4, all right, on our graph. we need 400 here versus a 4. So reading this information, we can see that that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each box represents 1. Okay? Going this side, this is like 100 on on how many boxes? All right? But do not worry about this because this is like 100, 200. We have got the multiples, these multiples here. 400, 500, 600. So do not worry about that. Unless if we want to read something, we're going to talk about that. All right. So it was going to be like this, 400 versus 4, meaning to say 400 is here. Then 4, we have to count 1, 2, 3, 4, where they meet with the 400 here. The 400 going up and the 4. They meet at this. You mark it as a point. So you're just going to count for 1, 2, 3, 4 going up. So this is 400 versus 4. So as you can see, your graph was going to start from the top. It was going to start from this point going up like that. The graph is supposed to start from the ground. So that is why we have to use the 300 versus what? 0. So you just need an extra class with a cumulative frequency of 0. So that's 300 versus what? 300 versus 0 like this, so that our graph is starting from the ground going up. All right. So let's move on, guys. We had 400 versus 4. The other one, 500 versus 15. All right. So that's 500 versus 15. This is 500 going up. So 15, we need 5 boxes going up from 10. That's 11, 12, 13, 14, 15. It was going to be somewhere there. All right. That's a 15. 500 versus 15. Another one, 600 versus 37. 600 versus 37. All right, this is where we have our 600. So you're going to need it up. So 37, this is 30. So just count 7 boxes. 1, 2, 3, 4, 5, 6, 7. Somewhere there, which is just 3 boxes from 40. 1, 2, 3. Yeah, so this is it here. All right, so that is 600 versus 37. Another one is 700 versus 50. All right, 700 is this one. So we need it versus 50. 700 versus 50. 700. This is 50. So 700 versus 50 was going to be somewhere there. All right. Mark those points. 800 versus 57. Remember, this is 850. Remember, this is 50. So 57, we just need 7 boxes going up. So it was going to be 60, 60, 59, 58, 57 here. So this is where we are going to have it. And another one, 900 versus 60. So 900 is this one. This one is for 900, this one. So 900 going up to 60. This is where we have our 60 there. All right. So this is these are our points. We have marked the points on the graph. Then we have to join these points. That's to produce a smooth curve. As we draw this, we are supposed to have a smooth curve. All right. So I might not have a smoother curve here, but try by all means to have a better curve in your presentation. All right, something like this. So that is your cumulative frequency curve. It was going to be something like this. All right. All right, something like this, starting from the ground, going up like that, up to the last point. All right, so let's just hope we are together on this one. Then with this information, with the graph that we have just drawn, the question was 1.3, use the graph in question 1.2 and determine the estimated median value for the daily sales. Use the graph. The question is supposed to be taken from this graph. How can we determine the median? In order for us to obtain the median, we need its position. We need the median position first. Before we talk of the median, what is its position? The median position, that is half of the distribution. Remember, this is grouped data, grouped information. When working with grouped information, there is no need of us using half of n plus 1. Half of the distribution, halfway going up. meaning to say halfway going up, half of what? The total value there, which is 60. Or you can use the information that you had before. Remember, on your total cumulative frequency, we have what? 60. The total number of days that we are given there, they are 60. So that's half of 60. 1/2 times 60, which was going to give us the 30th position. That's the position of the median, not to say this is our answer, but the position where our median is going to be obtained from. So from the 30th value, 30 there, on your cumulative frequency, you're supposed to draw this, take this horizontal line straight to the curve. You're supposed to take it straight to the curve. All right, so let me try and have something that we can use. So we're supposed to take this one straight from that point. All right, so let's take it straight from 30. This is a horizontal line to the graph. All right. Then from that point, you are supposed to take it down from that point, going down like this. So this is the corresponding value that we are going to have. So meaning to say, at this value that we have, we are supposed to count what is its value that is corresponding on these. That is the daily sales. Remember, the question needs you to find what? The median of the daily sales. What is the corresponding value that we are having there? So you take from the median, from there, this is your Q2. You take it down to the graph. What is the corresponding value? This is a position, but the corresponding value is what? So you're going to count according to the scale. So we need to understand our scale just like what we're doing going up. Remember, we're counting these values. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what about in this horizontal? How are we going to take our scale? 100 from how many boxes? This is 1, 2, 3, 4, 5. So we need to understand that if these 5 boxes that we see, if these 5 represent 100, what about each one? Each one represents what? Here it was easy, guys. From 0 to 10, you just count 1, 2, 3, 4, 5. What about here? How are you going to count in 5 boxes to obtain a 100? So you simply divide 100, divide by what? Divide by 5. Because they are subdivided into 5. 1, 2, 3, 4, 5, representing a 100. So if 5 represent a 100, what about 1? Simply divide 100 divided by 5. That's a 20. So meaning to say each box represents a 20. So that's a 0 there. Then we've got a 20, a 40, a 60, an 80, up to 100. So each box represents a 20 in this part of the cells. So meaning to say at this point, we've got 500, 520, 540, 560, and so on. All right. So according to our graph, as we can see from my graph here, it was going to correspond with what? 560. So that's 520, 540, 560. But on the actual presentation that I had, it was supposed to be 580. Remember, I was talking about the smoothness here. It is because of the smoothness of the graph. I don't know. What are you having from your graph? All right. So in that interval, 560 up to 580, whatever that you're going to obtain there. All right. So that is according to my graph there, it's 560. So you can obtain 570, you can obtain 580 according to your graph. It is still fine. All right. So that is how you're going to obtain this value. Let's answer another question. The tuck shop must make 475 in sales. All right. To break even. So they must make 475 rand. 475. So on how many days did the tuck shop make a profit? All right. In terms of the amount, these are our daily sales. So the question is, where are we going to have the daily sales that are corresponding at 5 at 475, the one that we are given there. All right. Let's save this this part here, guys. Let's see if we're going to understand our question here. Remember, they're saying in order for you to have a break even, the amount of the sales, the money that you're supposed to have is supposed to be 475. So let's consider to say at 475 rand, how many days are we going to suppose? Remember, the cumulative frequency is talking of what? A number of days. These are number of what? Of days that we have. These are the sales, the daily sales. So what is the corresponding value at 475? All right. So where is 475 from our graph? On the cells, where do we have 475? Remember, each box represents 20 on the cells. So this is 400, 420, 440, 460, 480. So meaning to say 475 is in between these points, 460 and 480, in between. We just need, just going to draw a line in between 460 and 480. All right. Remember, we need 475. So this is 460, just somewhere there. An approximate, guys. So it was going to be like this, just an approximate going up. So you take the value from that corresponding to the graph, straight to the graph. What is the value that is corresponding to your graph? Because what you need is the number of days corresponding there. So this was going up to the graph now. Then you go to the number of days. Guys, you are given cells. So from cells, you have to go to the number of days. The other one where we calculated the mean, the median, I mean, where we are dealing with the median, you add the median position from the number of days, which is your cumulative frequency, to the cells, because they wanted the median cells, the median cells for that month. There you need the days. So you work with the cells to the days. So as we can see from our graph, this number corresponding there is a 10. So meaning to say these days, 10 days that we see there, they are, remember this is 475. So we just say that is where we are to reach the 475. We have to take 10 days. So meaning to say the 10 days are to be considered as a loss. These 10 days, they made a loss. So on 10 days, it was a loss. All right. So on 10 days, there was a loss. All right. Or they made a loss. There was a loss. That is on the 10th day. That is when now when you say, okay, when we have the break even, now we start to make the profit. So the profit is now after this 475 going up to the end there to 900, which is corresponding to the last value there. The last value is what? How many days do we have on the last, the last value at 900. This is 900 here, the last value. The last value there at the end. It is corresponding at what? At 60. So the difference between the days that were of loss, 10 days of loss, from 60 days, what is the difference? The difference these days, 10 going up, those days they were of profit. So meaning to say, therefore, the profit was made in how many days? 60 minus 10, which is, we talk of what? 50 days. So the profit was made for 50 days, where we talk of greater than this value up to the end there. So it's 60 minus the 10 days of what? Of loss that we had. So that is how you're supposed to have attempted this question. Then also, on the first day of the following month, the tuck shop made 725 rand in sales. Does this day lie within the top 25% of sales from the previous 2 months? Remember, this information is of the 2 months, the previous 2 months. So they are saying the next month, on the following month, They made 725 Rand on the sales on the following month. So does this day where they made this 725 lie within the top 25% sales of from the previous month? The top 25%. What does it mean when we talk of the top 25%? The top 25%. The top 25%, according to our percentiles, it simply means the 75%, the top at the end. Remember, the percentage at 100. So we just have to remove 100 minus 25, which is what? 75%. So we're talking of 75% of the distribution of these 2 months. This is the previous 2 months, as we consider to say there is another month that is following. So this information becomes of what? The previous month. So from the previous month, the top 25% means 75% of the distribution. So that's 75% of the distribution, which is our N. Remember, our distribution N, the total frequency is what? Is 60 on that total cumulative frequency. So that is 75% of the distribution, which is which is going to give us 45. That is the 45 considering in terms of the position. This is the position that you're talking about there. So at this value, what is the corresponding cells at this position? What is the corresponding cells at that position? All right. So we need the position 45. This is 40 going up. So 45 is in between what? 40 and 50. Just have to count. That's 41, 42, 43, 44, 45 there. So going to the graph, straight to the graph. So the corresponding value, from there, you have to take it from the graph to the cells. So you must draw a line from this point where it is intersecting going down. So it was gonna be somewhere there. So that is, you have to take the value corresponding there, guys, which it was gonna be approximately at 650 there. That was the value that you're going to obtain, 650. So meaning to say, the top 25% starts at what? The top 25% starts at this value that we have there, which is 650. That's 650 Rand, approximately in between 600 and what? 700. In between that, that is where we have the top 25% of the cells. The 75%, it starts at this value. This is the starting point. So if this is our starting point, so the question is this 725 in within that value if it starts from 650? Yes, it is in within. 725 is more than 650. It's 650 going this side, top 70 going up. Talk of 700, 750, 800, 900 going up. So meaning to say thus, the 725 Rand that we have there lies in within that interval that we are given. So therefore, the 725 would have been in the top 25%. In the top 25%. So the top 25% simply means 75% of the distribution. If you talk of the quartiles, that is 3/4 of the distribution, which is Q3, the upper quartile. That is the top 25%. So this is how our questions might be given as. Question number 2, you were given 5 data values. You are already told that there are 5. That is 1, 2, 3, 4, 5 values that we are given. If the mean of the data set is 15, show that K is 11. If the mean of this data is 15, show that K is 11. So first of all, how do you calculate the mean? Because you're already given the mean is equal to 15, remember, you're told. The mean is what? Is 15. So how do you calculate the mean? In order for you to obtain the mean, remember that it is given from the sum of terms. This is ungrouped information. You're dealing with what? Ungrouped data. So that is the sum of terms of the number of terms. The sum, how many terms? The sum over how many terms? So meaning to say, we have it. The mean is already given. Our mean is 15. Is equal to the sum. We have to add 2k plus this plus this. We have to add that. That is the sum. So the first one, that is 2k plus, followed by k plus 1. That's k plus 1 followed by k plus 2. That's k plus 2 followed by k minus 3. So we have to add k minus 3. We add 2k minus 2. So this is the sum of terms over what? The number of terms. How many terms? 5 data values. There are 5. 1, 2, 3, 4, 5 terms. So you divide by 5. This is the number of terms. So with this information, guys, we're going to calculate the value of k, because this is an equation, the same as over 1. So you can even cross multiply. So that was going to be 15 times 5, which is 75. So 75 is equal to 1 was going to multiply everything on top. So this was going to remain as it is. So let us just take advantage of the like terms. Add these like terms. We've got 2k. We've got this k here, plus another k, plus another k here, plus these 2k that we are seeing here. So what we're going to have at the end. So that's 2 plus 1, which is 3, plus 1, which is 4, plus 1, which is 5, plus 2, which is 7. So that's 7k. The numbers that are remaining, that's 1 plus 2, which is 3, and 3 minus 3, that's a 0 there. So it was 3 minus 3, that's a 0. Then we remain with what? A minus 2. All right, so that's a minus 2. Remember this 5, we already what? Cross multiplied. 5 times 15 gave us what? 75. So this is where we are. We're just saving a normal linear equation where we can solve this. Take the minus 2 to the other side. It will be a plus 2. So that's 75 plus 2, which is 77. So 77 is equal to 7k. Divide by 7. Divide by 7 both sides. So therefore, our k was going to be what? 7 into 77 was going to give us 11. So this is exactly the value that we are being given. Show that k was going to give us an 11. All right, so that is it, guys. Our k there is 11. So with this information, that our k is 11, 2.2, calculate the standard deviation of these data rounded off to 1 decimal place. We're given an instruction to 1 decimal place, 1 decimal place. All right. So let's first have our numbers that are represented so that we can simply use our calculator there. So if k is 11, so let's find this. That's 2 times 11, which is 22. The following, that's 11 plus 1, which is 12. This is 11 plus 2, which is 13. This is 11 minus 3, which is 8. This is 2 times 11, then minus 2. That was going to give us a 20. So these are the numbers: 20, 22, 12, 13, 8, 20. These are our numbers if we substitute our k as 11. So with these numbers, determine, that is the question. We are supposed to determine or to evaluate the standard deviation. So on our calculator, guys, we can simply have our answer. This, we just need our calculator. Go to the setup. All right. So you're going to need the stat, this one, number 3. So press 3. All right. Under that, go to number 1. Under the variance, this one, number 1. All right. So we can insert our values. This is ungrouped information, remember? So you insert your values as they are. 22 is equal to, you insert another one, 12 is equal to 13, you press equal to 8, you press equal to 20 is equal to. All right, so cancel everything as if, okay, as if you just ignore this, just cancel. Then go back to the shift. Then you're going to use shift. Then you use this step, number 1. So shift, press 1, shift, then press 1. So under that, go to the variance on number 4. With this, number 3 gives us the standard deviation. Number 2 is of the mean. We do not want the mean. But if you want to see that mean that is 15, you can press that 2 and see that your mean is 15. That is to prove that your mean is exactly 15. But as we do not need the mean, we need the standard deviation. So let's cancel this. Go back, shift 1, press number 4 for variance. Then you press number 3. This is the for standard deviation 3. So as we can see, our answer is 5,215 and so on and so on. So to 1 decimal place, let's fix number 6 to 1 decimal place. That's 5,2. So therefore, our standard deviation in this case was going to be 5,2 to 1 decimal place. So like I said, that part you can simply use your calculator in the simplification. All right, so that is it, guys. On question 2.3, if T units are subtracted from each data, from each you subtract T units, you subtract a certain value. In each number that you have there, you subtract T, which is you subtract the same value, maybe it's 2, you subtract 2, you subtract 2, you subtract 2. Without further calculations, explain how the mean and the standard deviation would be affected in terms of T. As you are subtracting T, what is going to affect in terms of the mean? Is the mean going to remain as it is? Is it going to increase? No, the mean is going to decrease, all right? So the mean will decrease. You're subtracting, so that one is going to be a decrease, guys. All right, so you're going to have a decrease in the mean. What about the standard deviation? Standard deviation, as you subtract or as you add the same value, same value throughout, it is not going to be affected. So this standard deviation is not affected. Is not affected. The standard deviation or is unaffected. All right, so that is what you just needed there. Question number 3, considering our analytical geometry, you're given question in this diagram. Below, you've got triangle RPQ. All right, so this is our triangle RPQ. In this triangle, we've got the point PQM. M is the midpoint. This one is the midpoint. All right, so this is the midpoint as you are given of what? Of RQ. All right, so that is the indication of these two to show that from M to Q, it is the same as from M to R. All right, anyways, let's see. The question was 3.1, determine the gradient of the line MQ. The gradient of this line MQ from M to Q. All right, so remember you can just name X1, Y1, X2, Y2, and determine our gradient. All right, so that's 3.1. So the gradient of MQ, that is MQ. Remember the gradient is the change in Y over the change in X. Y2 minus Y1 over X2 minus X1. So that's Y2, which is minus 2 minus Y1, that's a 0 there, over X2, which is 4 minus X1, which is a minus 2, like this. All right, so that was going to give us what? Minus 2 minus 0, that's minus 2 over, that's a plus. 4 plus 2, which is 6. So this was going to give us a minus a third. Or from here, you can just use your calculator there. All right, so that's the gradient of the line MQ. It was going to give us minus a third, just in case we might need this value. Let's see another question, 3.2. Determine the equation of the line MP in the form y is equal to mx plus c. Remember, this is the gradient intercept format. All right, that's the 3.2, the the equation of MP. This is the line MP. All right, so let's start with the gradient. As you can see there, we need a gradient. So what is the gradient of the line MP? These two lines, we calculated the gradient of MQ. So it's either the gradient of PM, you're going to calculate it. It was a choice there. Or you can simply use the concept of the what? The gradient, because these two lines, they are perpendicular. They are at 90 degrees. So remember that if two lines are perpendicular, PQ, that's PM, this line, is perpendicular to MQ. It is perpendicular to MQ. So therefore, the product of their gradients should be -1. The product of their gradient, the gradient of PM or MP times the gradient of MQ must be equal to -1. Remember, for perpendicular lines. So meaning to say the gradient of PM times the gradient of MQ, which is the one that we calculated, minus a third, must be equal to -1. So simply divide by what? By minus a third both sides, so that we remove this. So that was going to give us what? 3 minus, that's a positive 3 actually. If you divide 1 divided by minus this, is going to be a third. So the gradient of PM was going to be +3. All right. So you have the gradient, or you could have just calculated this gradient, guys. The gradient of PM, you can just use the change in y over the change in x. So meaning to say the gradient of MP or PM, just use the change in y over the change in x. From the y values, y2 minus y1, that's 6 minus 0 over x2 minus x1, that's 0 minus -2. All right, so that's 6 over 2, which is 3. You could have even calculated that. So you have the gradient of the line, PM or MP, guys. If we say MP, PM, it is the same. They are just equal, guys. All right, so do not confuse on those two. So as we can see, we have the gradient. What about the y-intercept? The y-intercept is already there for the line PM or MP. The y-intercept, where the line crosses the y-axis, it crosses at the point 606. So the y value there is 6. So therefore, the equation was going to be determined with the gradient. Therefore, the equation of the line MP was going to be y is equal to the gradient, which is 3x. Remember, that's mx plus c. The y-intercept, it crosses the y-intercept or the y-axis at what? At 6. So that is the equation there. Y is equal to 3x plus 6, just like that. So if a gradient, then the y-intercept is there. All right, another question, determine the coordinates of R. 3 marks. R is this point that we see here, where we are told that M is the midpoint. All right, we are told that M is the midpoint. So let the point R be XY. All right. So using the midpoint concept, how do you calculate the midpoint, guys? Using the midpoint. All right. Using the midpoint concept. M, the midpoint, was calculated from what? X1 plus X2 over 2, Y1 plus Y2 over 2. We simply took the values of X, and so we just take the X value to the X value there, which means X plus, what is the X value at Q? That's a 4. Everything over 2 must give us the X value at M. This is our X at M. Remember XY. So X is what at M? -2. That's an equation. Solve for X. All right? That's an equation. With the same situation, with the same way, for the Y values, you have to take the Y value at point R plus the Y value at point Q, which is -2, over what? Over a 2. Must give us the Y value at M, our midpoint, which is what? Which is a 0. It's an equation. So solve. All right, so let's start with the first one. We can simply cross multiply. That's 1 times x plus 4, which is x plus 4 is equal to 2 times -2, that's a -4. So meaning to say x is equal to -4. The 4 to the other side becomes a minus. So x will be minus 8. All right, solving for y, this is same as over 1. So you can even cross multiply just like the previous case. So that was going to be, all right, remember plus or minus, guys, gives us a minus. So that's y minus 2 is equal to, if you cross multiply 2 times 0 there, that's a 0. So take the minus 2 to the other side of the equation, it will be a plus 2. So meaning to say y is equal to 0 plus 2, which is 2. So having this, therefore, the point R that we need is going to be given as what? Remember, a point is made up of x followed by y. So x is what? X is minus 8. And what about the y value? Y is 2. So that's our point R there. All right, just like that, we need another question. Calculate the length of PQ in a simplified Z form. The length PQ in Z form. All right. This is where we have our P and this is where we have our Q here, PQ. We already have our points. So remember the length, guys, is given by the formula. This is 3.4. So the length from the distance formula, that's x2 minus x1 squared plus y2 minus y1 squared. So from PQ, we're just going to need our point. This is P. We're just going to say x1, y1, Q. Let's just call this x2, y2. All right, so that's the square root of x2 minus x1. That's 4 minus a 0. So that's 4 minus a 0 squared plus y2 minus y1. That's minus 2 and a 6. So that's minus 2 minus 6 squared like this. So do not waste your time, guys. Z form under the square root. Use your calculator there. Simplify everything under the square root. That was going to give us 4 square root of 5 as you have it on your calculator. That is it in units. All right, so that is the length of PQ in Z form. Then given that RPQT is a parallelogram, determine the coordinates of T. If point T is in the third quadrant, if RPQT is a parallelogram. All right, this is what we have. All right, let me just remove this part so that we can understand each other. Remember, there we calculated R, this and that, the midpoint concept. So they are saying this is 3.5. So given that RPQT is a parallelogram. All right. We need to determine the coordinates of what? Of T. And T is in the third quadrant. Like we have R to P to Q. So T is in the third quadrant, maybe somewhere there like this. This is somewhere like this. All right. In the third quadrant. This is just a sketch, guys. All right. Just a sketch. Something like this. All right. So maybe this is where our point T is in the third quadrant, wherever that where it is. The concept is that if it is a parallelogram, what is it that a parallelogram does? Remember that these diagonals, they bisect each other. So the concept is on the diagonals. So as we have this diagonal from P passing through M like this to the other coordinate, and this from R to Q like this, which is another diagonal, they do bisect each other. Whatever line that we're going to have here, whatever point that we are saying it's our T that we are going to have this side, the diagonal, this one from P, this one, passing through M to T, is to be bisected, to be divided into two equal parts. So meaning to say M remains as the midpoint. M remains as the midpoint, the point M that we had before, the minus 2, 0. Remember our point M. So using the midpoint concept, guys, just like what we had, remember how you calculated the point R here. You use this midpoint concept. It is the same idea that you're going to do even on this question. You're going to simply use the midpoint concept to say, let the point T that we want to calculate be referred to as XY. So if it is XY like that, and M is the midpoint, this M, remember M is given as -2, 0, and it is the midpoint. How did you calculate that midpoint? PT. It is the midpoint of PT now. So it is the midpoint of what? Of PT this time. So using the point P and the point T, adding X together, X and X there, that's X plus a 0 over what? Over 2. Remember the midpoint concept, guys. We add X1. This was supposed to be X1 plus X2 over 2, Y1 plus Y2 over 2. So you have to add. You're supposed to obtain the X value at M, which is -2, just like the same way that the same way that we did, guys, on that point R. You do the same thing on the Y value. The Y value at T, which is Y there, plus the Y value at P, which is 6, over what? Over 2, must give us the Y value at the midpoint. And what is the Y value at the midpoint? M, that's a 0. So there are two equations where you can solve for X and Y. All right, so let's solve for X and Y, guys. This simply cross multiply. X plus 0, guys, that's X, which is equal to 2 times -2. That's a -4. Remember, 1 multiplies there. So X is -4. On the other hand, this is over 1. Cross multiply. 1 times Y plus 6. That's Y plus 6, which is equal to 2 times a 0. That's a 0 there. Take the 6 to the other side. It becomes a -6. So that's Y is equal to what? 0 minus 6. That's a -6. All right. So if Y is -6, therefore, we have the point T, because the point T is given by the X and Y value. The X, which is -4, and the Y value, which is a -6. That will be our point T. Okay. Just like that. So guys, questions can be, they want you to know the properties of the shape when it is like this. Do you know the properties of the shape? A parallelogram, diagonals bisect each other. Then explain why RPQT is a rhombus. The same RPQ that we had, and we said it's a parallelogram. Now we are saying it's a rhombus. How do you define a rhombus? A rhombus is a parallelogram with the diagonals that are perpendicular. So is it that our diagonals here, they are perpendicular? Yes. This is what is happening. Remember this diagonal here and this diagonal here. They pass, they meet at what? At 90 degrees. They are perpendicular. So in this case, we can say this is a rhombus because it is a parallelogram with diagonals that are perpendicular, or the diagonals of the parallelogram are perpendicular. All right, the diagonals of a parallelogram are perpendicular. They are perpendicular. They meet at 90 degrees. So that is the concept there. Remember your properties, the properties of the shape. So on question 3, that was it with this information you needed to apply that way. Then question number 4, you had the diagram below. In this diagram, there are lines AC and BD, they intersect at B. And these two, they are at 90 degrees. They are perpendicular. As we can see that these two lines, AB and BD, are perpendicular. Then we are given C and D. They lie on the y-axis, A and the X. All right, then the equation of AC is given. This is the equation of AC. While alpha is the angle of inclination of AC, and beta is angle C DB. This is angle beta. All right. According to this information, these are the questions that you had to answer on question number 4. First one, determine the coordinates of C. the coordinates of C. C is the y-intercept here. This is where we have our C. That is the y-intercept of the line AC. It is the y-intercept. So we can determine that, all right? So that's 4.1. So C, remember, it is the y-intercept. So if it is the y-intercept, it is on a condition where x is equal to what? Where x is equal to 0. Remember the y-intercept. So we're just going to substitute. In the equation of the line AC, we have its equation. That's py minus x minus 5p is equal to 0. So do not worry about this, that it's in terms of p or what. Know that for the y-intercept, x is equal to 0. So this one is a 0 there. So meaning to say we do not have anything. It's just py minus 0, meaning to say we are going to have py minus what? Minus 5p equal to 0. Remember, x is equal to 0. Solve for y there. So how can we solve for y, guys? We can take the 5p, the minus 5p to the other side. So it becomes a positive there. So meaning to say py is equal to 5p. You want to solve for y there, and you can see that p is common. So simply divide by what? By p both sides. So this can cancel. So y is equal to what? To 5. So meaning to say at this point C, the y value there is 5. So as a coordinate, as a point, that's 0, 5. That's the point C. All right. So we could have calculated this from the y-intercept concept. So therefore, the point C will be 0, 5. Remember, for the y-axis, x is 0 in the y-intercept, in the y-axis. Just like that. So guys, they are testing you this. Can you understand that? Or you could have just manipulated this. Remember, if you write your equation in the form of y is equal to mx plus c, y is equal to mx plus c. C is the y-intercept. So C is the y-intercept there as a point, but C here on the equation is also the y-intercept. So just make y the subject. Py minus x minus 5p is equal to 0. That's another way that we could have just worked this one. So meaning to say py is equal, you need to write in the form of y is equal to mx plus c. So py is equal to what? You take the minus x to the other side, it becomes a positive there. All right. You take the minus 5p to the other side, it becomes a positive 5p. So you need y the subject. So divide by p, divide by p, divide by p like this. So this was going to cancel. So y is equal to what? 1 over p of x plus, all right, guys, to write like x over 2, it simply means half of x. So the same x over p means 1 over p of x. All right. So here the p and the p was going to cancel. So you remain with a 5. So as we can see from this presentation of our equation, if we say y is equal to mx plus c, from this equation, if we say y is equal to mx plus c, c, the y-intercept is 5. So you will know that, okay, the point there is at what? At 5. So therefore, c will be 0, 5. All right? So that is how we could have calculated the point, the coordinates of C. So many ways that we could have done that. All right. Then on another question, if the gradient of AC is 1 over 2, show that P is equal to 2. If the gradient of AC, remember the line AC, we just have the point C now. There's nothing, we do not have point A or what. But they want us to find the value of P. Where is P? P is on the equation. Remember, if you used this way, if you did not use this way, guys, you are going to be forced to make y the subject of the, like this one, the way that I did here. After making y the subject of the formula, then you can consider determining the value of what? Of P. Why? Because in that case, if we are saying y is equal to mx, m is the gradient. And that m, according to this equation, is equal to what? 1 over p. Which is our gradient? And the same gradient that we are talking about, they told us that this gradient is what? Is 1 over 2. The gradient of AC, they gave us that the gradient of AC is 1 over 2. So if these two are equal, what is the value of P? We just have to equate these two. So meaning to say 1 over P is equal to 1 over 2. So what is the value of P? So P is equal to 2. Just cross multiply. P times 1, that's P. 1 times 2, that's a 2. So as we can see, guys, P is equal to 2, which is exactly what we are being asked to show, that P is 2. Then calculate the coordinates of what? The coordinates of B. And that is 5 marks for that. So in order for you to have the coordinates of B, we have to locate, guys. Where is our B? B is here. B is, that is where we have our B, the intersection of these two lines, line BD and line AC. This is the intersection. So meaning to say, we can simply solve simultaneously. It is the point of intersection. So you can solve our equations simultaneously. All right, that's 4.3. So let's start with this one. Remember, we made this equation in the form of this y is equal to mx plus c, the equation of AC. All right, so the equation of AC, we said y is equal to 1 over p. So that's 1 over p. Remember, p is what? Is 2. So that's 1 over 2x. So we've got 1 over 2x there. Plus 5. This is the equation of AC. All right, by substituting the value of P that we had there. All right, so that is, okay, so let's just also remove this part here. So meaning to say, if these two lines are to intersect, we have to solve them simultaneously. AC, we have got its equation. This is the equation of AC. But BD, we do not have its equation. So we are forced to find the equation of BD. So how are you going to determine the equation of BD? Remember that these two, they are perpendicular. BD is perpendicular to AC. All right? AC and BD are perpendicular. Remember that. So meaning to say, if AC is perpendicular to BD, the product of their gradients, the gradient of AC times the gradient of BD must be equal to -1, of which the gradient of AC is already there. Remember, this is gradient 1 over 2. So meaning to say 1 over 2 times the gradient of BD must be equal to -1. So what is the gradient of BD? Divided by 1 over 2. The gradient of BD was going to give us a -2. So BD, we have the gradient and also the y-intercept. Remember, the point D lies in the y-axis. So meaning to say, that's our y-intercept there, where x is equal to what? Where x is equal to 0, y is -10. So its equation was going to be determined. So therefore, the equation for the line BD was going to be y is equal to mx, that's -2x plus c, which is the y-intercept there at what? -10. So having these two equations, and we are saying the two graphs, they are intersecting, and at the point of intersection, these two graphs are equal. We can simply solve these equations simultaneously, since AC will be equal to BD. What is AC? This is our AC, which is half of x plus 5 is equal to BD minus 2x minus 10. So solve for x. As we can see, we have formed an equation that we can simply solve for x from there. All right, so you're going to take the minus 2x to the other side. It becomes a positive there. That's half of x plus 2x is equal to, take the 5 to the other side, it becomes a minus. So that's -10 minus 5. All right, so if you add this, you're going to get 5 over 2x. So that's 5 over 2x is equal to -15. That's same as over 1. So you can easily cross multiply. 1 times 5x, that's 5x is equal to 2 times -15, which is -30. So divide by -5. By -5 like this, x was going to be a -6. So if x is -6, to find the y value, we can substitute in any of these two equations. Remember, we're saying these two equations are the same. So you can substitute in either AC or in BD. All right, anyone of your choice. So substituting in AC, y was gonna be equal to half of x, which is half of x, which is half of minus 6 plus 5. All right, so we're gonna have the y value there. So meaning to say we are going to have minus 3 plus 5, which is a 2. So that's it, guys. We have the x value and the y value there, meaning to say we have the point that we need, which is our point B. So therefore, our point B there, the coordinates of that point B, with the value of x that we have, which is minus 6, and the value of y that we have, which is a 2, was going to give us what? Was going to give us the point B. All right, minus 2, 6. That's minus 6, 2. All right, that's it there. So as we can see, guys, questions can be like that. You have to also check the number of marks. 5 marks, there's a lot that you need to consider. There's a lot that you need to consider there. Then 4.4, determine the size of alpha. Remember, alpha is the angle of inclination of the line AC. This is where we have our alpha. And the line AC, we saw that the gradient of this line is half, remember? From the line AC, its equation was half of x. That was half of x plus 5. All right. So the gradient was 1/2 there. So you can simply take that from what we are given there. So meaning to say alpha, remember it's arctan of the gradient, which is arctan of the gradient of what? Of AC. So meaning to say that's arctan of the gradient 1/2. All right, arctan of 1/2. So that's it. So that was going to give us 26.57 degrees to 2 decimal places, as we are not given the instruction there. All right, then we move on to another question, 4.5. Hence or otherwise prove that AB OD is a cyclic quadrilateral. All right, from AB to O to D. Remember, we calculated this. This is 26.57 degrees. All right, so we need to prove that from A to B to O to D, it is a cyclic quadrilateral. All right, from this point A to B to O to D. If a circle was going to be drawn there, we're going to have it passing through these 4 vertices. Remember, a cyclic quadrilateral. So if it was like that, what is it that we're supposed to have? It's either we're going to prove that the angle at B, this one, of which you can see that this one, the angle at B is a 90 degrees. And the angle at O, this one, is also a 90 degrees. This can only happen that these two angles are equal if they are at the circumference of a circle. So that's another way that we could have just proved that. We can prove these two angles to be equal. If we can prove that, all right, so 4.5, these two angles, ABD, angle ABD is equal to 180 degrees minus 90 degrees, angles on a straight line, which is 90 degrees. So that is 90 degrees there. Then we know that AOD, angle AOD, is also equal to 90 degrees. This is from the quadrant, the angles of the 4 angles of a quadrant. Remember, they are 90, 90, 90, 90. So in order for these two angles to be equal, it means this is a cyclic quadrilateral. Therefore, ABOD is a cyclic quad. Is a cyclic quadrilateral. It cannot happen that, guys, this angle is 90 and this angle is 90. No, it cannot happen. It means a circle is passing through the angles at the circumference. Angles subtended by the what? By the same chord are equal at the circumference. These are the angles subtended by the same chord. Angles subtended by the same chord. All right, another way that we could have proved that a cyclic quadrilateral is to prove that if truly it's a cyclic quadrilateral, angle beta and angle alpha must be equal. So we must prove that beta and alpha are equal. How can we prove that beta and alpha are equal? All right. So let's find angle beta. All right. We are given that alpha is 26.57. How can we find angle beta? All right. Let's find the angle that is at C here. All right. Let's try find angle at C, this one. Remember, this one is a 90 degrees. So the angle at C, which is AC to D, AC to D or ACO, is going to be from 180 degrees. Remember, angles in a triangle, guys. So it's going to be 180 minus these two angles, the 26.57 and the 90 degrees angles in a triangle. That was going to give us 63.43 degrees. This is the angle that we have here, 63.43 degrees. Now, using that 63.43 degrees and this 90 degrees at B, we can calculate our angle beta. From 180 degrees, again, angles in a triangle. So we have to subtract the 63.43 and this 90 degrees on the other hand. Remember those two, that's the right angle that you're given there. So this was going to give us angle beta, which is 26.57 degrees. So as we can see, guys, these two angles are equal. For these two angles to be equal, for alpha to be equal to beta, guys, it means that's a cyclic quadrilateral. A, B, or D is a cyclic quadrilateral. Is a cyclic quad. There is no way that we can have that part here that we are seeing. If these two angles, guys, if these two angles are equal, by default, that would be a cyclic quad. We're talking about angles that are subtended by the same chord. It can be chord BO, it can be the arc BO, creating angle alpha and creating angle beta. It means it's part of a circle. It's inside a circle, and if a circle passes through these 4 points, it means it's a what? It means it's a cyclic quad. So that's how some of these questions, guys, might be given. We just have to understand our Euclidean geometry also as we are answering analytical geometry. See now, determine the coordinates of the center of the circle, which passes through DBC. A circle passes through DBC. If a circle is drawn and it passes through DBC, if a circle is drawn passing through these points, what is it that is important about that circle? Remember, in a circle, to have a 90 degrees like this from our Euclidean geometry, guys, this can only happen because it's a diameter which is subtending that. A diameter only subtends an angle of 90 degrees at the circumference. So by seeing this 90 degrees, by default, it tells us that C to D, this line is CD, is our diameter. So if CD is representing the diameter, guys, all right, see, CD represents the diameter. What about the center? Therefore, the center is the midpoint of what? Of CD. The center is representing the midpoint of what? The midpoint of CD. So if it is like that, guys, we simply need the values there to say our center is just going to x1, x2 over 2, y1 plus y2 over 2. Remember how you calculate the midpoint. The point you see, remember that was the y-intercept. You have these values, guys. It was 0.5. Remember, we calculated this before. So you just have to add x values. There's 0 there and the 0 there. That's 0 plus 0 over 2. The y values, the 5 and the minus 10. 5 plus minus 10 over 2 like this. So that was going to give us the center, which is 5 plus minus 10. That's a minus 5. So that's minus 5 over 2 like this. All right, so that's our center. In that case, from the midpoint concept. So the midpoint concept can help us determine or have the center. It can help us determine, it can help us have this center That is what it means from our presentation, guys. So looking into question number 5, we were given question 5.1, if 3 sine beta is equal to 2 and the cos of beta is less than 0. All right, determine with the aid of a diagram and without the use of a calculator the value of this. Let's consider our question properly here and try to understand the information that we are given. They gave us that the sine, 3 sine beta, so simply divide by 3, you're going to obtain the sine of what? The sine of beta. So the sine of beta is 2 over 3. And also you are given that the cos of beta is supposed to be less than 0. That's a negative value. If something is less than 0, that's a negative. Whereas the sine beta that we see is already given. We can see this value, guys. It's not a minus, it's a plus. It's the sign is not there, so it's positive there. We can properly see that this is a positive. So here, the ratio that we are given is a positive. There, they are saying the ratio that you are supposed to get here is supposed to be a negative, less than 0. So in which quadrant where we have sine being a positive and a cos being a negative, because we are supposed to use a diagram. That's where the quadrants play a role. Which quadrant is it that cos is negative, sine is positive from the cast? All right. Remember our cast concept. In the first quadrant, all of them, they are positive. In this quadrant, it is only sine which is positive. Meaning to say, if it is sine which is positive, what about cos? Cos is negative. Here, sine is negative. We don't want that. Sine is supposed to be positive. Here, cos is positive. We don't want that because cos is supposed to be negative. So this quadrant is out. This one is out. This one is out. So the best answer was supposed to be taken from the second quadrant, where sine is the only one that we have to consider there. Sine is being positive in the second quadrant. So that's where you are going to have your triangle in that quadrant. So having this, remember that sine from our ratio SOHCAHTOA, concept, sine opposite over hypotenuse. So this is opposite, this is hypotenuse. So this is our beta opposite, that is a 3, and the hypotenuse, which is what? So the opposite there is a 2. Opposite there is 2 and the hypotenuse is 3. So this is the part of the adjacent. You have to calculate the adjacent. You have to determine that adjacent so that you can determine all other ratios that are to follow. So how can we determine that adjacent? We can simply use our Pythagoras theorem. Remember, the Pythagoras theorem states that in this case, remember, this represents x and this is our y. So r squared is equal to x squared plus y squared. Hypotenuse, which is 3. So thus 3 squared is equal to x, which is the part that we need to calculate. And our x is in the negative region. So it's supposed to be a negative. So that's x squared plus the part of y there is a 2. So that's 2 squared. So 3 squared, that's 9, is equal to x squared plus 4. Take the 4 to the other side. It becomes a negative there, which is a 5. That's x squared. So introduce the square root, both sides. So meaning to say x is equal to, remember, plus or minus the square root of any number is plus or minus. The side that we are talking about is the negative region. In this region, our x is a negative. So that's a negative square root of 5. All right. So you must calculate that. Then we can answer our questions as we are being asked on question 5.11 to determine 3 cos squared beta minus 1. That's 5.11. So that's 3 cos squared beta. Cos, remember, cos is adjacent over hypotenuse. So we need the ratio of the adjacent over the hypotenuse. We square it. Then we subtract what? 1. So that is 3 into adjacent, our adjacent here, which is minus the square root of 5. over what? The hypotenuse. Our hypotenuse is 3. Remember, this is the hypotenuse. And hypotenuse there is 3. And everything must be squared. Then subtract a 1. So that's it, guys. So if they say do not use a calculator, guys, they are saying some simplifications like, but here you can just use a calculator. No one is going to know that you have used a calculator. They just use a calculator, multiply that. You were going to obtain 5 over 9 minus 1. Then we can simply also use your calculator to multiply these two. You're going to get 5 over 3 minus 1, which was going to give us 2 over 3 at the end. All right, so what they simply say, guys, do not just use your calculator to evaluate everything, but some of these stages, guys, you can even use a calculator. No one is going to know that you have used a calculator there. All right, so that's your 5.11, 5.12, which is the tan of minus beta minus 180. So first of all, let us reduce that into a ratio that we understand. All right, so that's 5.12, the tan of minus beta minus 180 degrees. All right, this is a negative angle. If you understand your negative angle, I think under trigonometry, I talked about these negative angles. You can even check other videos about trigonometry. I talked about negative angles. The angle of minus beta minus 180 is found in the second quadrant. It lies here in the second quadrant. That's where we have minus beta minus 180 degrees. So to write this angle in the second quadrant, we are talking about a tan. Remember from our cast concept, this quadrant, sign only is positive, meaning to say tan, there it's a negative. So it was going to be minus the tan of what? The tan of beta, which is the acute angle. In the second quadrant, tan is a negative. So you can use that as a negative angle. Or if you want, you can have it as a positive angle. Still, you're going to have the same ratio. How can we have it as a positive angle? You factor out that negative tan. That's minus beta minus 180 degrees. Factor out the negative, this one that we see. It will be tan minus like this, beta plus 180 degrees. All right. The minus that we see here, remember tan of a minus, tan minus, we are talking about the fourth quadrant where tan is considered as a negative. So this negative is going to give us negative tan. So it will be negative tan of beta, negative tan of the acute angle, which is beta. So as you can see, guys, we're going to have the same answer. So what is this negative tan beta? By obtaining the ratio, remember tan opposite over the adjacent. So that's a minus of what? All right. So this was going to be equal to minus tan, which is the opposite. That is 2 over what? The adjacent, which is minus the square root of 5. So that's minus square root of a 5 minus the square root of a 5 like this. So as we can see, guys, from this simplification, we have a negative and a negative that we are seeing. So these two, we're going to cancel. And at the end, we're going to have 2 over the square root of 5. You can even just leave it like that. At that stage, it's still okay like that. All right, so simplifications, guys, as you can see, they differ the way that you understand your trigonometry, but at the end, you're going to have the same answer there. Given that t cos 15 degrees is equal to 4. So this is simply a ratio that we simply need by dividing by t there. You're going to obtain a ratio, which is cos 15 degrees is equal to 4 over a t. Remember cos from that soccer here, adjacent over the what? Over the hypotenuse. So you can just draw your own right angle triangle, guys. This is a boss there. We do not consider to say, is it gonna in the first quadrant? Just draw a right angle triangle where you can indicate this is my 15 degrees. All right, this is my 15 degrees according to cos, adjacent and hypotenuse. So this is the adjacent. All right, remember this is the adjacent side. Angle and 90 degrees are adjacent to each other. So that's 4. The hypotenuse, which is t. You calculate the third side from your Pythagoras theorem, guys. It was going to be t squared minus 4 squared. T squared minus 4 squared, which is 16. That's t squared minus 16 under the square root. Use your Pythagoras theorem there, guys. I'm just going to write this in short, but you're supposed to use your Pythagoras theorem. Okay, just for the sake of revision, all of us to understand, guys, remember that Pythagoras, t squared is equal to 4 squared plus. This one you do not know. You're just going to call it whatever side that you want. You can even call it y, whatever that you want. You can even say y squared. So you take this to the other side. It's going to be t squared minus 4 squared, which is 16, is equal to y squared. Then you introduce the square root. That's t squared minus 16 under the square root. That's your Pythagoras theorem. So anyways, with that, or with these values that we just determined, that we calculate, we can also have this angle. Remember, angles in a triangle, they add up to 180 degrees. Already there's a 90 here. So the remaining angle, these are complementary. So it's simply 90 minus 15 degrees, which was going to be 75 degrees. So also you can also add this angle there. There's a 75 degrees. Or you can subtract from 180 degrees. 180 degrees minus 90 plus 15 angles in a triangle. 90 plus 15 degrees. Some of us want to do it this way. You are still going to get the same answer, 75 degrees. So that is it, guys. We have your triangle. Let's find sine 15 on 5.21. The sine of 15 degrees, remember your SOHCAHTOA, opposite over adjacent. According to 15 degrees, according to this angle, opposite is this one, and the hypotenuse is what? Is t. So opposite, that's the square root of t squared minus 16 over the hypotenuse, which is t. All right, that's just like that. 2 marks, 3 marks. So the diagram also is involved. Remember, you had the diagram. Then sine 75 degrees on question 5.22. Sine 75 degrees, again, opposite over the hypotenuse. What is the opposite of 75 degrees? According to 75 degrees, this is the opposite, which is 4. So 4 becomes your opposite. The hypotenuse does not change. So that is t. So it was going to be 4 over t. Just like that. All right. So let's simplify, guys. Another question, which is 5.23. 1 minus tan squared 15 degrees. All right, that's 5.23. 1 minus tan squared 15 degrees. And they're saying give the answer as a single fraction. All right, so let's check. What were we going to have? 1 minus, remember tan from the SOHCAHTOA, opposite over adjacent. According to 15, remember 15 opposite. The opposite of 15 is this one, the square root of t squared. The square root of t squared minus 16 over the adjacent. According to 15 degrees, the adjacent there is 4. But they are saying tan squared. So we are supposed to square this. That's a tan squared. All right, let's see. But they want this as a single fraction. So if you square this from your calculator, guys, remember, okay, without even our calculator, guys, to remove the square root. By squaring this, you are removing the square root. You're simply neutralizing. That's removing the square root, meaning to say you are going to remain with t squared minus 16 over what? You also have to square. The 4 is not under the square root. Remember, it is not under the square root, that 4. So raise it to the power of 2 as it is. 4 to the power of 2, that's 16. 4 squared, that's a 16. All right, so that's it, guys. Let's have it as a single fraction. We are subtracting. So lucky enough, this is 1, and 1 can be expressed as a denominator of any number. If you're given 16, that's 16 over 16. If you're given 7, 7 over 7. So that's a 16. We can write or rewrite this 1 that we are seeing here as a denominator of 16 as 16 over 16 minus this t squared minus 16 over 16, like that. So this allows us to simply subtract because the denominators are the same. So we can simply subtract. So it will be 16 minus, but take note, this is an expression. So it must be put in a bracket. T squared minus 16. We are subtracting, yes, but under this 16 having a negative, which is true, but having what? A bracket. It must be inside a bracket to show that everything has to be subtracted. Everything must be subtracted. So it's going to be 16 minus times this t squared. That's minus t squared. minus times a minus 16, that's a positive 16, everything over 16. So let's collect our like terms, guys. The 16 and the 16 there was going to be 32. So that's 32 minus t squared over 16. So that's it, guys, as a single fraction. Remember your instruction, as a single fraction, as a single fraction. So this is how your questions, guys, are given as 3 marks for that. 5.3, express or simplify the following to a single trigonometric function without the use of a calculator. All right, 5.3. So let's try to reduce, guys. The cos of 90 minus alpha from our co-function, remember, it is equivalent to the sine of alpha. This is the sine of alpha times. This is a negative angle. We can factor out the negative that is common there. So it is going to be the sine of a negative like this. If we factor out this negative, these two will be positive. So it will be alpha plus 540 degrees. All right, alpha plus 540 degrees, everything over what? Tan 225. Remember, 225 is in the third quadrant. That is where we have 225. So it was taken from where? If this is 225, what is the relationship? It is simply means 180 degrees plus, what is the difference between these? This is 180 degrees, remember. So we need the acute angle. So the acute angle will be 225 minus 180 degrees. All right, so 225 minus 180 was going to be 45 degrees, meaning to say the angle in between there is 45 degrees. And in this quadrant, we know that tan is a positive there. Remember your cast concept, tan is positive. So writing it as tan of an acute angle, it was going to be written as tan 45 degrees as a positive. All right, plus sine alpha. There's nothing that you can do there. Just write as it is, sine alpha. Sine 180 plus alpha. As we use this, remember 180 plus alpha lies in the third quadrant also as a positive angle. Remember, I talked about this, guys, positive angles. This is where we have 180 degrees plus alpha. In this quadrant, it's for tan. Sine is a negative there. So sine is a negative. So it's the minus sine of alpha that you're going to have there. Sine is what? Is a negative. All right. So this is where you are. Let's try to reduce this part, the sine minus there. So you're going to have the sine of alpha times the sine of a negative. Let's reduce this, guys. We understand that if sine is a negative like this, it simply means minus sine like this, minus sine, minus sine. Sine is a negative of what? Of alpha plus 540 degrees. 540 degrees is an angle which is bigger than 360 degrees. So we have to reduce it. Subtract 360 degrees. 540 minus 360 degrees was going to give us 180 degrees. As you can see, 180 is in within the interval. So it was going to be minus sine of alpha plus 180 degrees. Guys, where do we have sine alpha plus 180? Sine alpha plus 180, this one that we talked about here, we saw that it will give us a negative at the end. So it was going to be a negative this one. Take note, guys, there. A negative this one that we already have. But the sine of alpha plus 180 changes or reduces to be a minus sine alpha. As we saw, it will be a minus sine alpha like this. So meaning to say minus minus gives us what? A positive. That's a sine alpha at the end. So this whole part here that we are seeing, this whole part of sine minus this whole part, it is the sine alpha in short. It is the sine alpha that we see there in short. All right. So I just hope, guys, you saw this simplification. Let's move on to another part. What about tan 45? We know this from our special angles. Tan 45 is 1. All right. Then they've got a product sign and a sign. That will be minus. Remember, plus and the minus there. That's a minus sine times sine. That's sine squared alpha. All right. It becomes interesting as we are at this stage because we can see that this is a product. Sine times sine, which is sine squared. So we are going to have sine squared alpha over what? 1 minus sine squared. 1 minus sine squared alpha. Remember from your Pythagorean identities, the cos squared of alpha plus the sine squared of alpha is equal to 1. So in order for us to have 1 minus, we have to take this to the other side. In order to have is this one, the sine to the other side. So meaning to say you remain with what? Cos squared alpha, which is 1 minus what? Sine squared alpha, by taking this sine squared to the other side. So wherever we see a 1 minus sine squared alpha, this one, what is it that we see? We see a cos squared. It is equivalent to a cos squared alpha. And we know that sine over cos, if it is sine alpha over cos alpha, it gives us a tan. So if it is a squared like this, it means it will be also a tan squared. So this is the final value that we can have, the final answer that we can have at the end. We can simplify to this stage and say, there we are done. We cannot simplify further because there we just have a single trig that we have. If we consider another question, 5.4, we are given this, from this identity that we are given, that we have, or a trigonometry that we are having there, 1 minus cos of theta is equal to 2 sine squared theta. Then they are saying, show that the equation can be written as, it can be factorized like this. All right. How can we write this equation? We have to check, guys. The equation here is in terms of cos. We can only see cos. But on this equation that we are given here, we can see that there's a sign that we have. There's a sign. So let's get rid of this sign that we are having there, because we have a sign there. What is that equivalent? We saw that from our Pythagorean, guys, from that cos squared theta plus sine squared theta is equal to 1. So to have a sign, we have to take the cos's to the other side. So meaning to say sine squared theta is equal to what? 1 minus cos squared theta. Wherever we see a sine squared, this one, we are going to replace with its equivalent, 1 minus cos squared. All right, so let's replace this. Because we can see that it's in terms of cos. So our answer is to be related to cos also. All right, so that's 1 minus cos theta is equal to 2 times this sine squared, which is this one. So it's 2 into 1 minus cos squared theta. All right, so that's 1 minus cos theta. Expand by 2. That's 2 times 1, which is 2. 2 times this, which is minus 2 cos squared theta. So that's a quadratic equation. As we can see, the highest exponent that we see there is a 2. So take this to the other side. It was going to be 2 cos squared theta. Already there is a minus cos theta on the left-hand side, minus cos theta. Take the 2 to the other side. There is a 1 there, so it's 1 minus 2, which is minus 1. That's equal to 0. We can see that's a quadratic equation, just like a normal quadratic equation that we are used to. So you can factorize, depending with the way that you know your factorization. I don't know which way that you are used to. So as for me, I'm going to multiply the first term to the last term. 2 cos squared times minus 1 was going to give us negative 2 cos squared theta. So we need the products or the multiple or the factors in that case, all right? The products or the factors of minus 2 cos squared theta. But if you add those two, you must get the middle term that you're given here, which is minus cos theta. If you add, so multiply the two numbers or the two terms, you get this. But when you add, you must get the middle term. So which two? That's a minus 2 cos theta and cos theta. If you multiply these two, you're going to get minus 2 cos squared. If you add these two, you're going to get minus cos theta. So these two terms, replace them into the middle term here. In this middle term that we see, replace them. So it is going to be 2 cos squared theta. We replace these two, minus 2 cos theta plus cos theta minus 1 is equal to 0. As you can see, guys, This is a quadratic having 4 terms. So using the factorization grouping into two terms, what is common there? 2 cos theta is common. So you can factor 2 cos theta, divide. That's going to give us the cos of theta. Divide this -2, and this is going to give us -1. So as you can see, this part and this part are the same. Cos theta -1, cos theta -1. So we have to factor out a +1 so that it remains as it is, as cos theta -1. That's equal to 0. So as we can see, guys, the two brackets are common. So factor the common bracket cos theta -1. You remain with what? 2 cos theta and a +1 in another bracket. So it's going to be 2 cos theta +1. That's equal to 0. So as we can see, this is the equation exactly that we're supposed to show that you're given there. So like I said, how to factorize after this at this point, it's in your hands. You can even use other ways. There are so many ways, guys, as you consider your factorization of quadratic expressions. Nothing has changed. You still use that concept of your quadratic expressions. All right, so as we can see, guys, after factorizing, you are going to obtain exactly these two brackets that we see there. Then from there, hence, determine the general solution of a cos. Remember, dealing with a cos. So to have a general solution, let's determine the reference angle and the quadrants where we know the cos is going to be. Remember, cos, we need the angle plus 360 degrees times k, where k is an element of all the integers that we can think of, any integer. So we need the angle there from the quadrants, but from the reference angle first. All right, so let's take this, guys. One bracket is equal to 0 there. 2 cos theta +1 must be equal to 0, or this bracket must be equal to 0. Cos theta -1 must be equal to 0. Let's start with the first one and finish, work out everything from there and see what we're going to have. All right, so let's see. That's 2 cos of theta is equal to what? 1 to the other side becomes a minus. Then simply divide by 2 both sides. That's the cos of theta. Remember, we need a single trigonometric ratio. Before we consider anything, we must have a single trigonometric ratio. So that's equal to -half. From there, determine the reference angle. And remember, I said the reference angle, ignore the negative that you have there. Just determine without the negative, that is arc cos of 1/2. Ignore the negative. That was going to give us the reference angle. From there, we need what? The reference angle, which was going to be 60 degrees. The negative that we see there is of the quadrants. That's where the quadrants play a role to say which quadrant from the cast concept, where we have cos being a negative. As you can see here, it's what? A negative. Where is cos a negative? In the second and in the quadrant, because in the third. Because in the fourth and the first one, cos is positive there. So how do you determine the exact angle theta in the second quadrant? Remember, in the first quadrant, guys, theta is equal to the reference angle. In the second quadrant, theta is equal to 180 minus the reference angle. Theta is equal to 180 degrees plus the reference angle. The fourth quadrant, theta is equal to 360 degrees. You must know this, 360 degrees minus the reference angle. Because it must be which quadrant is it. Then you know how to take theta, the exact angle. We are dealing with a cos being a negative. So we are talking about the second and the third quadrant. All right? So in the third quadrant, our theta was going to be what? So talking of the third quadrant, our theta was going to be 180 minus reference angle, which is 180, minus the reference angle is what? The reference angle is 60 degrees. But this theta that we are talking about must be added to 360 degrees plus k. Like I said, remember the general solution of a cos. So we're going to add 360 degrees times what? Times k. So that is our theta. Was going to be 180 minus 60. 180 minus 60, that's 120. So that's 120 plus 360 degrees times k. And this k is representing all the integers. All right, we are done with the third quadrant. This is the second, guys. The second. Why am I writing third here? This is the second. I hope someone saw this. Say, no, 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 no. This is the second quadrant. The third quadrant also cos there is what? It's a negative. So what are we going to have there? All right. So let's consider in the third quadrant, our theta is going to be what? 180 plus reference angle. So that's 180 degrees plus the reference angle, which is 60 degrees. So that's plus 60 degrees plus 360 degrees times k, just like what we had before. All right, so that's it, guys. We just have to add these two. 180 plus 60. That is going to give us 240. So we've got 240 degrees plus 360 degrees times k. So that's it. And this is representing all the integers. So that's it about this theta from this reference angle, where cos is a negative in the second and in the third quadrant. Second and third quadrant. In the fourth, cos is positive there. And in the first one, cos is positive there. So we're done with the first one. We move on to another part. Remember, there are two things that we had. This equation and this one also. So we move on to the other one, where cos theta minus 1 is equal to 0 degrees. All right, we need to do the same thing. Cos theta minus 1 is equal to 0, meaning to say as a single ratio, that's a 1. Determine the reference angle, but dealing with the 1, we are supposed to know this. Even if you were to determine your reference angle, guys, it's going to be arc cos of 1, which was going to be 0 degrees. Angles such as 0 degrees, 90 degrees, those are special angles that you need to know where exactly cos is at 1. Even this you can understand from the graph of a cos. Remember, the graph of a cos is like this. Where it is at 1, it's at 0 degrees, and at what? At 360 degrees. So we're not going to use the 360, just use 1. All right. So even if you use the 360, it's not a problem. So there, we cannot use this to say which quadrant, but it's a 0 that we have there. 0 straight at 0. So 0 goes back to the 360. Yeah, that is where the 0 is. So which quadrant is that? First and last quadrant. So we just use that as the 0 degrees. So therefore, our theta was going to be, from this one, our theta was going to be the angle, that's 0 degrees, plus, remember, general solution, 360 degrees times what? Times k, where k is element of all the integers. So these were the three solutions that we're going to have all in all. The first one that we got in the second quadrant, third quadrant, and this one that we got from this one that it gave us one. So all these were going to be part of this solution. They're going to be part of this solution. So guys, you have to be careful. Simplifying these, you have to be careful. All right, on another question, question number 6 are given in the diagram below. The graph f of x, that's tan x minus 1, gx minus half x cos 2x are drawn from minus 90 to 180 degrees. These are our graphs. Write down the period of g. So as we consider the period of g, that's from minus 90 to 180. So the period there is what? It's 180 degrees there. So that's 180. Okay, guys, 1 mark. These ones are supposed to know the range of g. Where is g taken? Remember, range, these are the y values. So as we consider the graph of g, the lower value is this one. The lower value corresponding there. The bigger value is there. So you can even substitute 0 degrees. At 0, what is the value that is going to correspond? Remember, g is this one. You substitute as 0 there. All right? Just to see what's going to happen there. So it's minus cos as 0. That is what we have. All right? From the graph of g. So that is the consideration that we have. So meaning to say the value that is corresponding there is a half. On top there. Down there at 90 degrees, the value that is corresponding there on our graph is what? Minus half. So the graph of g as it is going there is going to go to the half on top. In between. Going down there, minus half. At 90 and at what? At 0. So those are the limits in terms of the y value. In terms of the y values, it will be taken in between minus half up to a half. So y is limited in between those. It must be greater than or equal to minus half. The same y that we are talking about must be less than or equal to a half. In between, y is supposed to be taken from minus half to what? To a half. Okay, so that's the consideration there. So with this information, they want you to use these graphs to determine graphically on the graph 6.31 where f of x is greater than or equal to 0. F of x is greater than or equal to 0. Where is it from our graph? Where is it from our graph? Where f of x is greater than or equal to 0. This is the x-axis where y is equal to 0. Where we talk of y, we talk of f of x, we talk of gx. Y value is at 0. So when you say greater than 0, it's supposed to be above. We need where this graph is above the x-axis, above this line of y is equal to 0. Where is it that we have our f on top of the x-axis, above the x-axis? That is what we need. Where is it that we have this f? Remember, this is our f. So we can see that it is above the x-axis from this 45 degrees here going up. That is where f is above. If we check here, it's below the x-axis. If we check this side, it's below the x-axis. This is your x-axis. Remember this one, your x-axis. Here it's below, but here it's above. In within this, from 45, in between these values, remember the values that we talk about there, that is here. The x values are the one that we need. So it's in between what? 45 degrees, 90. It cannot reach 90 degrees because 90 degrees is what? An asymptote. So x must be greater than or equal to, because we have that. So it must be greater than or equal to what? 45 degrees. But less than 90 degrees, because 90 degrees is an asymptote. It cannot reach 90 degrees. It cannot be at 90 degrees. It's an asymptote, that one. The value cannot reach 90 degrees. It cannot reach that one. All right. So that's it on 6.31. 6.32, where we have f of x by gx is greater than 0. What does it mean when you are given something like this? F of x by gx is greater than 0. All right, that's 6.32. The product of f of x and the product of gx to be greater than, remember, this is 0 there. But the product of these two to be greater than, it means either the two, they are in the negative. Remember, negative times negative gives you a positive. Greater than 0 means bigger than 0. This is a positive. So to have a positive, it's either the two functions are negative. The two functions are in the negative region. Being in the negative region, that is below the x-axis, you measure that by the x-axis. Below the x-axis, that's where we talk of the negative values. Above, positive. So it's either both are in the negative or both are in the positive, because positive times positive gives us what? A positive. Negative times negative gives us what? A negative, a positive. So these are the regions that we want, where both are negative or both functions are positive at the same time, simultaneously. At which condition? All right. Let's take here from minus 90 degrees, going to 45 degrees here. In between this, we can see that both functions are in the negative. This one is below the x-axis. This one is also below the x-axis. Both are in the negative. The moment we move from that 45 degrees, the moment we move from this 45 degrees, this g is now on top. As you can see, g is now above the x-axis. It's now in the positive region. Whereas f is in the negative. This one is in the positive. This one is in the negative. So we don't want that. We want a condition where both are negative. Like what we can see, this one is negative, this one is negative, in within this minus 90 and 45. Remember, 90 is an asymptote, minus 90 is an asymptote. So the first solution that we can see from that one is that x is supposed to be greater than minus 90 degrees. But the same x is supposed to be what? But the same x is supposed to be less than minus 45 degrees. We are comparing in between minus 90 and 45. If we compare between minus 45 to 45 degrees here, we can see that one is positive, another one is negative. So we do not want that because both are supposed to be negative or positive. Let's move on from 45 degrees. From 45 degrees, we can see that F is now in the positive region. It's on top. F is in the positive. What is happening at that moment? G is below the x-axis, as we can see here in this interval. G is below. It's in the negative. So we do not want that. One is positive, one is negative. We do not want that. Up to what? Up to 135 degrees. There is no solution there. Let's move on to, all right, no, up to this one, up to 90, because there's an asymptote here. So up to 90 degrees. So because there is an what? An asymptote here. So we are talking about from 45 to 90 degrees here. From 45 to 90, there is no solution there. Let's move on from 90 degrees, all right? This is where we are, all right? Remember, we are judging with this one, So from 90 degrees, this is what is happening. 90 degrees here, guys, we can see that G is in the negative. This is your G from 90 to 135 here. G is in the negative. In that same interval, we can see that F is in the negative also. This is F, the whole of F this side is negative. We can see that F is negative. It's under the x-axis. So both functions are negative there. Both, they are negative. So we also need that solution. So another solution was going to be taken in between that interval where both are negative. We are talking about interval from what? 90 to 135. So x is supposed to be greater than 90 degrees, bigger than 90 degrees, but less than 135. That is what we need. Moving on from 135, we can see that from 135, G is now on top of the x-axis. It's now in the positive region, whereas F is in the negative. So we cannot take this region because one is positive, one is negative. So we cannot take that. So the best solution was going to be within these two intervals. That is where we have both functions being greater than 0. All right. 6.32, 2 tan x plus cos 2x is equal to 2. So if you're given this type of a question, you must be very, very careful. With this type of a question, you must be very, very careful. That's 6.33. Let's just try to check what is it that they wanted us to do. Remember, they are saying you must use a graph. They gave us 2 tan x plus cos 2x, which is equal to 2. And they are saying the solutions are supposed to be taken from we are supposed to use the graphs. We are not supposed to solve this as an equation where we start to solve in our own way. We are supposed to take it from the graph. But where is it? Where are these graphs? Because we don't see any graph of 2 tan x. We see the graph of tan x minus 1 and this one of minus half cos x. So what happened for them to have this equation? Let's try to analyze what exactly happened. What if we equate these two? The tan of x minus 1, we equate it to minus half cos 2x, because you can see that these two are on the same equation. Tan and cos, they're on the same equation. So something about equating there happened. All right, let's try to have it this way. Remove the fraction, because you can see that this is 2. So you can remove the fraction, multiply by 2, multiply by 2, multiply by 2 like this. So that was going to give us 2 times tan, which is 2 tan x. All right, minus 1 times 2, which is minus 2, is equal to this one, and this one was going to cancel. You remain with minus, this is minus 1 cos x, which is same as minus cos 2x. This is 2x, sorry. Then take the minus 2x to the other side, it was going to be a positive there. So it was going to be 2 tan x. You take the minus this one, it becomes a positive there. So it was going to be positive cos 2x. You take the minus 2 to the other side like this, it was going to be a positive there, positive 2. Are you seeing, guys? This is the same equation that we see. So it was actually formulated from these two graphs being equal. Tan x minus 1 represents what? F of x. It was actually taken from f of x being equal to what? Minus half cos 2x represents what? Represents gx. So they're simply saying, where is it f of x and gx are equal? Where is it that they are equal? At the point of intersection. We are talking of at the point of intersection. This is the point of intersection. So if it is at the point of intersection where these two graphs are equal, let's take them. Where is it that we see the two graphs intersecting? Because they're saying use the graphs. Use it from here. Where are we seeing our graphs intersecting? These two graphs, they meet here. That is where they intersect. At what? At 45 degrees. The x value is the one that we need. So therefore, our x was going to be 45 degrees at the point of intersection where the two graphs intersect. The two graphs are intersecting. That is what they simply needed there. All right. On another question, they're saying if hx is given as this equation, describe the vertical translation. They already told us that is a translation of h from f. From f. What was our f before? Remember, our f of x was given as tan x minus 1. So from this f, how did we transform to this hx? Okay, let's consider our hx, guys. They said it's sine x plus cos over cos x. Remember, cos can be divided into each of these ones. So it can give us sine x over the cos of x. Let's try to separate like this. There's a plus, so it's going to be plus the cos of x over the cos of x. You can separate each sine over cos, cos over cos, where we know that sine over cos is what? It's a tan. So that's tan x plus 1. This one and this one are going to cancel. So our hx, in a simplified manner, we can see it that it's tan x plus 1. So what happened? Which transformation? They already told us is a translation, and we can properly see that. Minus 1 is the effect there on y there. It is transformed up to 1. You transformed from minus 1 up to 1. Going up, you're going up, guys, to say this is where we have minus 1. This is where we have a plus 1. So how many units that we have from minus 1 going to a positive 1? How many units do we have? There are 2 units. Remember, there is a 0 in between. So that's 1, 2. So this is 2 units going up. That's vertically up. So that is 2 units upwards. So it went upwards from minus 1 to positive 1. It went upwards 2 units going up. All right, 6.5, you are given that determine the maximum value of px if px is 4 gx. If px is 4 gx. All right, so let's consider this. If p of x is equal to 4 gx, what will be the maximum value? Let's determine px. Because we have the gx. What is our gx? This is our gx. Substitute there, 4 times gx. That is minus half cos of 2x like this. All right, we multiply this. 4 times minus half. 4 times minus half, yes, that's a minus 2. So that's minus 2 cos 2x. Remember the value that we see here, the minus half that we see, tells us that the graph is going to be taken from the maximum, which is a half, to a minimum, which is a minus half. If you are given the graph of tan, the same concept, if you're given the graph of a cos, the graph of a sine, you can use that concept. So if you have a minus 2 like this, it simply tells you a graph is going to be taken from minus 2 up to positive 2. So the maximum value will be what? Will be positive 2. So therefore, our maximum value there was going to be positive 2. So therefore, maximum value will be 2. So that is it, guys. You could have answered that way. We can simply take it from there. Same thing like what we have here on the range of G. From our equation, we can simply take it that way. Because we've got maximum, minimum, we can see that the minimum will be at minus half, the maximum will be at positive half. So meaning to say your range, y is greater than or equal to minus half, less than or equal to half. From that concept, from this understanding, you can also use it that way. So this is it, guys. You just need to consider your mathematical calculations, as many questions as you can. On question number 7, there is a figure that you're given below where there's a triangle ABC. This is our triangle ABC, which is right angled at B. And we're given the angle P. This is it. And we're also given that CB is 3AB. The length of CB, this one, is equal to 3AB. It is equal to 3AB. If AB is given as it is as AB, CB is 3 times of AB. All right? Then the other angles, DCB 135 and this distance 121 meters. Determine the value of P on 7.1. Correct to 3 decimal places. To 3 decimal places, you are given an instruction to use. How can we determine the value of P? Which concept? What can we use? Working with the non-right angle triangle is going to be complicated because we've got so many things that we need. We do not have like a complete ratio to be used. A complete, something that is complete that can be used. Is it the cosine rule or is it the sine rule? But working from triangle ACB, this one, we can see that it's a right angle triangle. This one, ACB, it's a right angle triangle. In this triangle ACB, we can see that we can apply the ratio because we've got something that is complete according to angle of our P that we are given, this P, relating to side AB because CB is given in terms of AB. We can say that this is the opposite. The one that faces the angle, remember, is your opposite. And CB becomes our adjacent. Remember, it's a right angle triangle, so you can use the trigonometrical ratios. SOHCAHTOA. Which ratio is it where opposite and adjacent are used at the same time? That's a tan. So meaning to say from the tan of the angle, which is the tan of P, you're going to equate to the opposite, which is AB, in terms of AB, because AC, this CB is given in terms of AB. So the ratio was supposed to be AB over CB. This was supposed to be our ratio. But remember, they told us that CB is 3AB. CB is 3 times of AB. So you can write it as 3AB like this, which we can cancel the AB and the AB. That gives us 1 over 3. So we have a ratio that tan P is equal to 1 over 3. So what about the angle P? Because P here represents the angle. So the angle is going to be arctan. All right? So that's arctan of what? 1 over 3. Just like that. So that was going to give us the angle P to 3 decimal places. That was going to give us 18,435 degrees. All right. So we have our angle P there. All right. On 7.2, they want you to use P as 18,4. If P is 18,4, they want you to use that. Determine the length of CD. What is going to be the length of CD if P is 18,4? CD is in triangle CDB, this one. That is where we have the length of CD. But they are saying if P is 18,4, but this angle is P over 2. So you're going to take that triangle. So in triangle, I'm just going to use in triangle BCD. Let's just call BCD. Angle P here is P over 2. So remember they said P is 18,4. So divide by 2. 18,4 divided by 2 was going to be 9,2 degrees. So this angle is given as 9,2 degrees. We have to divide by 2. So there's an angle that we are given, which is 9,2. There's an angle that we have, which corresponds to a certain side. And also, there is an angle that we are given of 135, which is corresponding also to a certain side of 121. And it's a non-right angle triangle. That's why we have to relate like this to say which part is going to work. So you can see that the best was going to be the sine rule, where an angle corresponds with a side. The angle corresponds with the side that we want. So remember your sine rule, guys. A over the sine of A is equal to B over the sine of B is equal to C over sine of C, this and that. These are sides to be calculated. Any side. So which side are we calculating? CD. So it is going to be CD over the sine of the angle corresponding to CD. CD is facing 9,2. So it's over sine 9,2 is equal to the other part that is complete. 121 over its corresponding angle. So that's 121 over the sine of the angle that is given there, 135, the one that corresponds. So let's find our CD. Okay, we can use our ratios, cross multiply, or you can just remove this sign. 9,2 is a division. So how do you remove this? Simply multiply by 9,2 both sides. You multiply by sine 9,2 degrees both sides. This was going to cancel. You have your CD. So our CD was going to be the product of this. This is same as over 1. Just use your calculator to simplify the product of this. So now we can use back our normal degree of accuracy to 2 decimal places. It was going to be 27.36. Remember, this is in meters. The length is taken in meters. So that's it. Just like that. All right. Question number 8, you're given in this diagram below represents an open tank. So they are saying this tank, it's open on top. Here it's open. So the dimensions as we have, it's X. So meaning to say there's an X which we do not have. There is another X here that we do not have. It's open on top. This top part is not there. All right. So these are the dimensions, the sides, X centimeters, and the height that we are given, which is H. Going up, the height is H. Going up, the height is H. But the sides are X. Like this is X, and so on. So the question was, determine the height of the tank in terms of H. Remember, there is a volume that you're given there. And we understand that volume is equal to the area of the base times the height. The area of the base, what is it that we have on the base down here on the base? What is it that we have? That's a square, because this is X, this is X. These sides are the same. This is X, this is X. All these 4 sides will be X, X, X. This is the height, this one. H is the height. But we talk of the sides, the length and the width. That's a square. So the area on the base is the area of a square. So it's side squared times the height. So the volume, we have it. 490 is equal to side squared, which is X times X, which is X squared. Remember, it's a square. So that's X squared times what? Times the height. So that's it. But we need H. So how do you find H? Simply divide by X squared. Remember, you need H. So divide by what? By X squared. This was going to cancel. So therefore, H was going to be 490 over X squared. It was an advantage that we simply took from the volume that we are given, the expression of the volume that we have there. All right, that's area times the height. The base area times the height. All right. On another question, they need you to determine or to show that A, which is the external surface area of the tank, is given by the formula. This is the formula. The area. Remember the area, we're talking about everything that we see, but you're told that it's opened on top. So if it is open on top, the area was going to be given. The base that we see here is not going to repeat itself because it's open on top. We do not see it. So we're going to have the area of a square only here on the base, this one, on the base. Then we have got these faces that you have got height and x. Remember, there is this x and height, x and I, these ones. How many of these do we have? There is this one that we see on this side, which is 1, corresponding to this one on the other hand, there are 2. We see it also here. This is height and this is x. It is the same surface that is going to be appearing on the other end there. There will be, remember, this is solid, guys. What you see on one end is appearing on the other end. What you see on one end is appearing on another end. So there were going to be 2 height times x plus another one that we see, like we say, this one on this face, this one. There's another face at the back that will be showing the same thing at the back of the box that we see there. So we still have another one, 2hx. Yeah. So these are simply the same. These are simply the same. X squared was supposed to be multiplied by 2 because there is another square on top, but we are not going to take it because they told us that it's an open tank. There's nothing on top, so you cannot take that. But it was supposed to be like this too. But we cannot take that. So you see the application of the question. Read to understand the question. All right. So this is it. Let's add this x squared. These are simply the same. So you're simply going to add 2 plus 2, which is 4. So that's 4hx. All right. Let's substitute our values. Remember, the answer there is given in terms of x. We can see that it's given in terms of what? In terms of x. So we have to remove the h that we are given there and substitute with x. So it's going to be x squared plus 4. H, remember h, we have it in terms of x. H is what? H is given as 490 over x squared, like this. All right, times the x that is already given here. So this is it, guys. This is the same as over 1 over 1. So we are going to have our a as x squared plus, all right, let's cancel x and x into x squared, that's x. So multiply the numerator to the numerator, 4 times 490. We have to multiply these two, so it was going to be 1,960 over 1 times x times 1, which is x. All right, so as you can see, guys, this is the area that was being given there that we are being asked to show that it's going to be like this. And after that, they want you now to calculate the external surface area of the tank, given that the tank is 10 centimeters high. If this tank is 10 centimeters high, remember this is your area, this one in square centimeters. Now they are saying, determine the area if the height is 10 centimeters. But our area is not given in terms of the height. No, look properly, guys. Your area here is written in terms of x. But they gave us the height to say the height is 10. Why are they giving us the height? Where we have x. We must find x. From where? Remember, there's a relationship that we wrote about the height here on 8.1. We said h is equal to 490 over x squared. And we are told that the height is what? The height is 10. We are told that the height is 10. So if this height is 10, find the value of x, substitute in place of h. So that means 10 is equal to 490 over x squared. We need to find the value of x from there if our h is 10. So divide by what? Divide by 1. Then you're going to cross multiply these two. That's going to be 10 times x squared, which is 10x squared is equal to 490 divided by 10, divide by 10. That was going to give us x squared, which is what? 49. So introducing the square root, x was going to give us a 7. All right, we know this is length. So we just take our length as a positive value. So if x is 7, we can determine this area here. Because they said determine this if the height is. But you have to calculate what? X first. After that, we can determine our area because our area is in terms of x. So if our area is x squared, what is our x? Our x is 7. So that's 7 squared. So therefore, our area was going to be 7 squared plus 1,006 and 1,960 over x, which is over 7. Remember, our x is 7. So that was going to give us 329 square centimeters. Remember, our area being measured in square centimeters. So they wanted you to understand that concept to properly take the information that you had calculated before, manipulate the equation that you had in terms of x so that you can solve for x or just substitute them. You calculate your x values, and after that, you can now determine your area. All right, on question number 9, we are given a diagram that we needed to use. In this case, they gave us all this information. You can see the center, which is at O, and they wanted you to use this diagram provided the angle subtended by the same, right? I don't know what happened with our question here, but they wanted you to prove that the angle subtended, the angle at the center is twice angle at the circumference. They wanted you to prove that this angle, ROQ, they wanted you to prove that angle ROQ is equal to 2 times angle P. Angle at the center is twice angle at the circumference. Using this diagram, how can we prove? All right, let's start. Remember from our proofs, guys, we talked about these proofs. We can simply go around and check those questions. I said the easier way, we can join this from O to P. This one, OP. All right, to P like this. Meaning to say this line, as we have joined this, all right, so just gonna write join PO, external OP. By joining this, you are creating angles at O. This will be O1 and this will be O2. At P, we can say this is P1, this is P2. All right. So in the relationship of our angles, we do understand that. Remember, there's a triangle that we have in triangle Q or P like this one. The angle O1 is an exterior angle, this one. It is an exterior angle. The angle O1 that we see here is an exterior angle, which we understand that the exterior angle is equal to the sum of the two opposite interior angles. Remember your concept of the exterior angle, guys. The exterior angle of a triangle is equal to the sum of the two opposite, this one and this one. Opposite interior. Opposite are the ones that add up to this. So meaning to say angle O1, if we are to take it into consideration, it is equal to angle P1 and angle Q. Sum of these two. It is equal to angle P1 plus angle Q. We're talking of what? The exterior angle of a triangle. Remember, I'm just going to write in short, exterior angle of a triangle. But in this same triangle, from O to Q, it is equal from O to P, the radii concept. OP is equal to what? To OQ from the radius concept. So if these two are equal, therefore, it tells us that angle Q and angle P1 are equal. Angle Q and angle P1 will be equal. Angles opposite what? Equal sides. So I'm just going to have this in short. Angles equal opposite what? Angles opposite, sorry, equal what? Equal sides. If these angles are opposite equal sides, therefore they are supposed to be equal. They're supposed to be equal. So let's get rid of this, guys. We said P1 plus Q, but we are saying Q is same as P1. So what does it mean? We can write Q as P1 in place of that. Therefore, we can have this as angle O1 is equal to angle P1 plus Q. Q is same as what? Is same as P1. So if you add P1 plus P1, what are you going to have? You're going to have 2P1. All right? That's our angle O1. Using the same idea or using this same concept that you just answered this question, you can have it in terms of O2. Relate it in terms of O2. All right? So for O2, this angle O2, you're going to have the same concept. O2 is the sum of what? P2 and what? And R. From the same exterior angle. This are the opposite interior. So angle O2 is equal to the sum of angle P2 and angle R. We are talking of the same reason. Exterior angle of what? Of a triangle. The sum of the two opposite interior angle there. Then from the radius concept, OP, this line OP and line OR, they're the same. Radii. The radius is supposed to be the same. So if OP is equal to OR, therefore it means these two angles are the same, angle R and angle P2. Those two angles will be equal. The angle at R there and the angle at what? At P2. So therefore angle R and angle P2 are equal. Same reason, angles opposite what? We talked about this, guys. Angles opposite equal sides. So if these two are equal, we can remove where our angle R is and substitute with what? With P2. So it means our angle O2 will be equal to what? P2 plus P2. So it was going to be angle 2, P2 like this. So let's analyze now the theorem that we are being given, because we are talking of O1 and O2 separate. And we said this O1 that we are seeing here is 2P1. That's angle 2P1. Angle O2 is 2P2 like that. So adding these together, determining the whole of the angle O that we are seeing there, adding those angles together, guys, what were we going to have? What were we going to have? Because we remember we need the angle ROQ. That's why we're talking about angle O there. That's why we're focusing with angle O, because what we need is angle ROQ. So you can see that angle ROQ is the sum of what? 2P1 and 2P2. That's 2P1 plus 2P2. Factor out the 2 which is common. That's 2P1 plus P2. All right. Is it the same as angle 2P? What is angle P? Angle P, guys, is the sum of angle P1 and P2. So if you use it that way, in place of P, you substitute this here. It's going to be the same. It's going to be the same. So you can see that this is exactly what the theorem is stating. This is exactly what the theorem is stating. O1 and O2 is giving us this. Exactly what we are given there. So therefore, we can say ROQ is equal to angle 2P. Angle at the center is twice angle that is given at the circumference. So questions of proving, the best way is to work out as many questions as you can. Just try to go through questions of proving, because it's just going to be a repetition. And if you know this, it's just going to be a repetition. In the diagram below, we are given DF is a diameter. So this DF is a diameter. Remember, a diameter subtends an angle of 90 degrees at the circumference. So this diameter, DF, it must create 90 degrees at the circumference. The whole of angle E is supposed to be 90 degrees. All right, then we are given the chord EG intersects with the DF at H. All right, this one we have got a 90 degrees there. They are perpendicular. And we are also given an angle of 55 degrees here. With this information that we have, determine giving reasons. Whatever that you're going to have, you must give a reason. 9.21. Angle A, the first one, angle D. How can we determine angle D? This one. Angle D. So you can see that, guys, angle D is a straightforward question. Let's consider the chord EF. This chord EF. It is creating the angle at G. The same chord EF, it creates the angle at what? At D. They are created by the same chord. So these are angles subtended by the same chord, or angles in the same segment. So they are equal. Remember that they are equal. So in this case, our angle D was going to be 55 degrees. So this is 55 degrees. Angles in the same segment. So I'm just going to write in short, angles in the same segment, or angles subtended by the same chord or the same arc. Angles in the same segment. All right, that's segment there. All right, let's consider another angle, which is angle O2. All right, from this, we need angle O2. This is where we have our O2 there. Okay, what can we do, guys? If we consider this chord, same chord EF, it creates an angle at D like this. It creates an angle D. The same EF that we are seeing here, it also creates an angle at O like this. It creates an angle at the center and creating an angle at the circumference. The same chord. What is it that we know about a chord? When it subtends an angle at the center, and the same chord, it subtends an angle at the circumference. The angle at the center is twice. So we multiply it by 2, which was going to be 110. So this by 2, or you can use even this one at G. Same thing. Angle at the circumference, angle at the center, one and the same thing. You multiply by 2. Angle at the center is twice angle at the circumference times 2 of that. All right. So this whole angle there was going to be 55 times 2, or use this one, 55 times 2. It's one and the same thing. So that was going to be 110 degrees. That is, angle at the center is twice angle at the circumference. So that's 110 degrees. So you can just write it in short like this. Angle at center is equal to 2 times angle at what? At circumference. At circumference 2 times. That is twice. All right, that's about our angle O2. Then we move on to angle E2. E2, this one here. Remember E there, if there's E1, there's E2. That is this part here only. That is where we have our E2. How can we determine this angle E2? What is it that we have that we can use? All right. If we are to consider properly, we can see that. Remember, H is 90 degrees. That means H2 is also 90 degrees. This one is a right angle. It's a straight line. So this one is also a 90 degrees there at H2. Using this theorem, guys, this theorem you're supposed to know it. Guys, this theorem is very, very important. The exterior angle of a triangle is equal to what? The sum of the opposite interior. So if we consider this theorem, it was working here properly at this E to H, extending this line like this. We can see that in this triangle like this, in this triangle that I'm presenting, this one, you're going to see that 110 is the exterior angle. This is where we have 110 here. And the 90 degrees is part of the opposite interior angle. What about this one? This is the one that we call E2. So E2 was going to be calculated from there. We could have used that concept. So to find angle E2, we can simply subtract from what? 110 degrees. The exterior angle. Remember, the sum of these two must give us the exterior angle. So we are given the exterior angle is already there. So it's minus what? The other angle that we are given, which is 90 degrees. Because if we add these two, we must get 90. So subtract 90 degrees from 110. You are getting the other angle that is remaining. That was going to be 20 degrees, meaning to say this is 20. So if this angle is 20 degrees, guys, 20 plus 90 is what? 110. So that's our E2. We are talking of what? The exterior angle there. It was going to be on the exterior angle of a triangle. Just like that. All right. So guys, you have to be very, very careful there. All right. What about E3? E3, let's check where our E3 is. Our E3 is here. So this is where we have our E3, the remaining part here. Remember, this is E1, E2, E3. So how can we find E3? Which concept can we use? What can we do? All right. If we are to consider these guys, we can see that there is O to E is this one. From O to E, it's a radius. And from O to F, it's also a radius. So meaning to say the angle that we have, all right, the angle that we consider E3, remember opposite, these angles that are opposite to the equal side, they're also equal. So it means angle E3 must be equal to angle F1. These two angles are supposed to be equal angles that are opposite what? Opposite equal sides. So if these two angles are actually equal, we can determine these angles because there is a 110 degrees angle that is inside of the triangle. So we just have to subtract that from 180 degrees. So we just have to subtract from 180 degrees, we subtract 110 degrees, then divide by 2 because we are saying these two angles are equal. Just like that. So it was going to give us 70 degrees over 2, which is 35 degrees. So meaning to say this angle is 35 degrees. The angle there is 35 degrees. Just like that. We're talking of angles inside of a triangle. That's the reason that you can put them. All right. On another question, they want you to determine the length of OH. If the diameter of the circle is 10 units and GE is 9,4 units, determine the length of OH. Determine the length of OH. All right, so let's try and see what is happening here. All right. Remember, we want to determine the length of OH here. That's 9.22. All right. We want to determine the length of OH. And what is it that we are given? We have the diameter 10 and the GE 9,4. So the diameter, we need OH, given that the diameter is 10 and we are given the length of GE 9,4 units. 9,4 units. All right, this is what we have, guys. This is the information that we have, and you have to calculate OH. OH from O to point H, this one. This is where we need length. All right, let's try, guys, and see. Remember that we had this angle was 20 degrees. I'm just going to remove some of this other side. So let's consider that the diameter is 10. So meaning to say from O to E, that's a radius. Half of that. Remember, radius is half of the diameter, so it's 10 over 2, which is 5. From O to E is going to be 5 units. From O to F, from O to D, as long it's from the center, it's going to be 5 units. So here to be 5 units, here to be 5 units. From O going to this side of OD, it's going to be 5 units also. From the radius concept, it follows that OD is also 5 units. Because OD consists of what? Of OH. So if we know this, guys, and they gave us GE, why giving us GE? This one. GE, this one. They're saying GE is 9,4. And we need to calculate OH. As for this GE, I'm not going to use this one because there's nothing that we need from that 9,4. What can we do with it? G to E. All right. Unless if we are to take it this way, all right, the 9,4, you can use it. If we want, we can use it. Okay? We can. There are so many ways. If you want to use the GE, because this line, as you can see, is from the center. This line is from the center and it's at 90 degrees to the chord. So it means it bisects this line into 2 equal parts. From G to H, it will be equal from H to E. So meaning to say that was going to give us the length of HE or the length of G to H. From this GE, we're going to have GH is equal to HE, which is equal to 9,4 divided by 2. So we have to divide that one, 9,4 divided by 2, which is 4,7. So that was going to give us 4,7 units, meaning to say this is 4,7. I can even remove this angle here. So there is 4,7. There is a 4,7. So remember the question, you want to calculate the length of what? The length of OH. So guys, if you wanted to use that, you can use that, meaning to say this is where OH is, and it's a right angle triangle. You're left with, this is what we have, guys. There's so many, this one, there's so many ways, guys. You're remaining with something like this. This is your E, this is your H, and this is your O. And remember I said this is a right angle here. From O to E, it's 5. From H to E, it's 4,7 from our calculations, remember? So you can calculate HO, guys, or OH. Which is this one, OH that we want. It's there. It's a right angle triangle, so you can use our Pythagoras theorem. From Pythagoras theorem, what does it mean? Hypotenuse is squared, OE squared, that is OE squared is equal to what? The shorter side, which is OH squared, and the other shorter side, which is HE squared. We have the length of OE. From O to E, that is what? That is 5. So 5 squared is equal to OH, which is the one that we need to calculate. So that's OH squared plus HE, which is 4,7 squared. I'm just going to take this to the other side. It becomes a negative there. So it's just going to be 5 squared minus 4,7 squared. You take it there, it becomes a minus, which is equal to what? OH squared. OH squared. So to determine OH, simply introduce the square root. Square root here, the square root here. You have your OH. So OH was going to remain from the square root that you are given, which is the square root of 5 squared minus 4,7 squared. That was going to give us the length to 2 decimal place. It was going to be 1,71, 1,7058, which is 1,71 units. That's the length of OH using the Pythagoras theorem. Let's say you wanted to use that length, this and that. So it was up to you guys. It was up to you. Or let's say we do not want to even have this OH calculated. This OH that we calculated, it's a waste of time. From this diameter that we have, remember we said this length here is 5. It's like this. Guys, in this triangle, we can see that it's a right angle triangle. Remember, there's an angle that we have inside of this triangle. This is where we have our E. This is our H. This is O here. There's a right angle that we have. And there's also an angle inside. Remember, when we calculated this, we say the angle at E is what? Is 20 degrees. And we know that EO is 5 units. So using the concept of a right angle triangle, we can calculate, guys, the length of OH according to the angle that we are given, 20 degrees. What is that we have? Opposite. What about 5? 5 does not change, the hypotenuse. Which ratio uses opposite and adjacent at the same time from our SOHCAHTOA concept? Opposite, hypotenuse at the same time. That's for sine. So the sine of the angle inside there, sine of 20 degrees, must be equal to the opposite, which is OH, over what? The hypotenuse, which is 5. So you can calculate OH from there. All right, this is over 1. So simply cross multiply. That's 1 times OH, which is OH is equal to 5 times sine 20 degrees. So that was going to be 5 sine 20 degrees. So that was gonna be another way of determining OH. So 5 sine 20 degrees on your calculator was going to give you 1,71 units. That is to 2 decimal places. You're going to have 1,71. So like I said, there are so many ways on solving this one. There are so many ways that you can actually use, guys, as long you are applying your information properly. There are so many ways there. All you just need is to make sure that you use the given information, or you apply the given information properly. So many ways there. So if we consider question number 10, we are given in the diagram below, AT is a tangent. So that's AT is a tangent at T. Then we are given the chords BT. That's the chord, this BT given. All right, and this other chord and this other chord. Then AC is parallel to TV. This is where we have AC, and this is where we have our TV. These two lines are parallel, given the indication there of the parallel lines. BC is equal to CV. From B to C, and from C to V, that is these two, they are equal. That's the indication that we are given there. And there is an angle X, which is representing BVT. From B to V to T, the angle that we are given there is X. So with this diagram, having analyzed your diagram, the question was now, determine with the reasons 3 angles that are equal to X. 3 angles equal to X with reasons. All right, let's consider where X is. X is here. This is where we have our X. Which other angle that we can use, and with which reason that we can use there, that we can say truly they are equal? We are told of the lines that are parallel, and we can see that they were creating a Z, alternate angles, the concept of our N, the Z concept. If you're given this, you're given it as N like that. These angles, they are equal. Alternate angles, we do understand that they are equal. So if we have that Z or the N that is being created here, we can say the angle that it is at B1 and the angle V2, they are equal. So this B1 is also equal to X. Alternate angles, they are parallel lines there. All right, so that's 10.1. You can consider angle B1 to be equal to X. What is it that we are talking about there? Alternate angles. Like I said, I'm just going to write in short. Since these two lines are parallel, since AC is parallel to TV, all right? Since AC is parallel to TV. Another part equal to X is which angle? All right, they told us here about angles which are the same, that are equal. I mean, there's the sides which are equal. BV, this BC, and this CV. From B to C and from C to V. Remember that if two sides are equal, the angles opposite those sides must be equal also. So by default, angle V1 must be equal to X. Angles opposite what? Equal sides. So this V1 was also going to be X. So there we can see that angle V1 also was going to be X. We are talking about what? Angles opposite what? Equal sides. If they are opposite, equal sides, they're supposed to be equal. So this angle and this angle, they're equal. All right, the sides opposite, like this. All right, another condition, this that we need, we also need another X. All right, let's see. This is X here. Let's consider the tangent. A to T is a tangent. A to T is a tangent, remember? And we do understand that the angle between a tangent and a chord, angle between a tangent and a chord is equal to the angle in the alternate segment where the chord, this chord BT, where is it creating an angle? That's the angle in the alternate segment, which is X here. So the angle X that we see is the same as the angle between the tangent and the chord. So angle T2 was also going to be equal to X. That's an angle between what? A tangent and a chord. So you can just write in short, tan chord theorem. All right. So you can write in short, angle between a tangent and a chord is equal to the angle in the opposite segment. So that's your tan chord theorem. All right. So that is it. For 6 marks, it was okay. It was fine. So this is what we have. And 10.2, if ATVC is a parallelogram, prove that AT is equal to BT. All right. With all this information, remember this, then they're saying, if we have from A, this part to C to V to T, this part, ATVC, this A to T to V to C like this. If this is a parallelogram, if truly it is a parallelogram, prove that AT must be equal to BT. How can we prove that AT is equal to BT? How? If ATVC, this one, is a parallelogram, remember, a parallelogram, we know that opposite sides, they'll be parallel and what? Parallel and equal. Opposite sides, they'll be parallel and equal. So how can we prove that AT from A to T, it is equal with this length BT, this one, BT. All right. They want you to prove on the length of BT. Okay, let's see, guys. What is it that we have here? In this triangle, we can try and see if we can use either angles in a triangle, something like that. because we can see that AT, this side of AT, it is equal to CV. But is it helping us for now? It's not helping us. All right. Remember the properties of a parallelogram. The angle that we have at A and the angle that we have at V, they are equal. Opposite angles of a parallelogram, remember, they are equal. So the whole of angle V, this one, you have to add x plus x, which is 2x. So meaning to say angle A and angle V are equal, which is x plus x, that's 2x. We are talking of what? Opposite angles of a parallelogram. Remember that when dealing with a parallelogram, the opposite angles, they are equal. Opposite angles of what? Of a parallelogram. They are equal. So meaning to say this will be 2x. Can we determine angle B3? If we can have B3, therefore we can say, we can relate in terms of the sides, because this B3 must be equal to 2x. So where can we have B3? And B3 must be equal to 2x. How can we calculate angle B3? All right, let's consider this and see properly, guys. We have to see properly. If we check here properly, B, C, V, T like this is a cyclic quadrilateral, this one. It is a cyclic quad. Where we do understand that in a cyclic quadrilateral, like this, we know that the exterior angle is equal to the opposite interior angle, this one, opposite interior, this one. These two angles, they're equal. So are we seeing that if this is a cyclic quadrilateral, angle V, the whole of angle V that we see here, must be equal to angle B3 also. Exterior angle of a cyclic quad. So that's another part to be considered. B3 is also equal to angle V, which is 2x. So this is 2x. This is exterior angle of a cyclic quad. You're talking of what? The exterior angle of a cyclic quad. So you're just going to write in short, exterior angle, cyclic quad. The exterior angle of a cyclic quad is equal to the opposite interior. So that's x plus x, which is 2x. So guys, if this is 2x and this also is 2x, what does it mean about the side AT and BT? They must be equal. These are sides opposite what? Equal angles. Sides opposite equal angles. So therefore, you can say these two are equal. AT is equal to BT. Sides opposite. In this time I talk of sides, not angles, but sides. These are sides. Opposite equal angles. Just like that. That's the reason now. All right. So the other question was to determine the size of X. So to determine the size of X, we must have a theorem behind that, which is complete. So what can we use? Is there any theorem that we can use? Is there any property of a triangle? The property of a quadrilateral? I don't know. Anything that is complete that we can use. Is there anything that we can use? All right. This triangle is not complete. BCV is not complete because we do not have angle C. This one is not complete. Triangle BTV, this one is not complete because we do not have angle T1. We do not have angle B2. Triangle ABT is complete. All angles are there. Angle A, angle B2, B3, angle T2. All the angles in this triangle are given. And we do understand that angles in a triangle, they add up to 180 degrees. So in that case, you can use, that is using triangle ABT. So using triangle ABT, we know that the sum of interior angles must add up to 180 degrees. Thus, we're going to add the 2x plus another 2x that we are given, plus this x that we are given. We are supposed to obtain 180 degrees. We are talking about sum of interior angles there. This is sum of interior angles of what? Of a triangle. They add up to 180 degrees. So adding these 2 plus 2 plus 1 there, that was going to give us 5x, which is equal to 180 degrees. So simply divide by 5 by 5. That was going to give us the exact value of x. 180 divided by 5, which is 36 degrees. So that was going to give us the value of x as we are being asked there. So we just have to use what is complete. If there is a theorem, use a theorem which is complete from there. If there is a theorem, you use a theorem. You just have to apply the concept that you are given in that question. All right, on question number 11, we are given, this is, all right, this type of a question, guys, you just have to study and understand information that you're given. There we are given, DE is a tangent to the larger circle at E, then also DE is a tangent to the smaller circle at E, this and that. So read your information and also see, according to this information that you're given, these two circles, they also intersect like what we can see them. All right, this is what we have, guys. Study your diagram. After studying your diagram, the question was, complete the following. Angle D3 is equal to what? And the reason is supposed to be exterior angle of a triangle. So you just have to focus where D3 is. Where is our angle D3? And consider the triangle that is being affected. This is where D3 is. Which is created by which triangle, which makes it to be an exterior angle. Where is it extended? It's being extended from this line going to H, meaning to say we are talking about this triangle here. This triangle like this. So meaning to say D3 as our exterior angle must be related to angle H1 and angle E1. We are given the reason already there. All right, so angle D3 is the sum of those two. That is angle H1 plus angle E1, as we are given the exterior angle of a triangle as our reason. All right, then we are asked on the other part there, prove. All right, then we need reasons there to prove that. DEFH is a cyclic quadrilateral formax. We have to prove that DEFH. So we have to consider from the point D, that's 11.2. So that's DE FH. All right, this is what we have there. DEFH is a cyclic quad. So you need to prove that this is a cyclic quad, guys. It must give us a cyclic what? Quadrilateral. All right, what is it that you can give in terms of a cyclic quad? If we are to draw a circle passing through D to E like this, to F, to H, let's say a circle was drawn like this. To prove that it's a cyclic quad, we must have any theorem about a circle, guys. As long there's a theorem about a circle. As long there's a theorem about a circle, it means we are having a cyclic quad because the points are on the circle. D, E, F, and H, they are on a circle. So is there anything that we can use to prove that it's on a circle. Anything that we can use. All right. We talked of angle D3 before. Let's continue from there and try to figure out. We said before D3 is the sum of these two angles, H1 and angle E1. Remember, this is what we had before, which is given. We already talked about this. We already calculated this from the exterior angle of what? From the exterior angle of a triangle. So if we have this D3 written in terms of H1 and E1, is there any that we can use to figure out what is going to happen inside? Because if there is a circle there and it's a cyclic quadrilateral, the exterior angle, this one, must be equal to the opposite interior angle. Meaning to say, it must be equal to this angle at F, which is F1 and F2. So we must prove that F1 and F2 together is the same as D3. If we can prove that, then it's a cyclic quad. So can we prove that? How can we prove that F1 plus F2, which is angle EFH, is equal to D3? How can we prove that? All right. Angle EFH, this is the one that we want to prove, is equal to the sum of these two, angle F1 and angle F2. Is there a relationship that we can take? All right, let's start with angle F1. Angle F1, this one, can it be related to any of these, H1 or E1? Because they're supposed to be equal. So let's relate from there. The hint is already there, guys. The hint is that these two are supposed to be equal. So is there anything that relate from F1 to E1 or to H1, any of these two? So we're seeing that at E1, because of what? Remember the concept of a tangent. Angle between a tangent and a chord is equal to the angle in the alternate segment, where the chord creates an angle, the chord creates an angle at F1. So it means this angle F1 and angle E1, they are equal. These two. Angle F1 is equal to angle E1. Angle between a tangent and a chord is equal to the angle in the alternate segment. That's our tan chord theorem in short. So you talk of what? The tan chord theorem there. All right. We are left with what? F2. What about angle F2? Can we prove that? Because definitely we have proved that F1 and E1. So definitely, guys, what is remaining is F2 and what? And H1. So we have to prove that F2 and H1 are the same. Are these two the same? F2 and H1, are they the same? Again, tan chord. There's a tangent here and a chord. So the chord is creating angle where the chord HE, HK, this one, is creating the angle at what? At F2. So angle between a tangent and a chord, which is this one, this is the angle between, must be equal to the angle created by that chord. This chord is creating the angle at what? At F2. So F2 and H1, truly they are equal. Tan chord theorem again. All right. So we simply talk of what? The tan chord theorem again. So if these two are equal, guys, and we said D3 is equal to H1 plus FE1. Here we are saying EFG is equal to F1 plus F2. What does it mean? It means EFH is equal to F1 is equal to what? F1 is equal to E1. What about F2? F2 is equal to what? F2 is equal to H1. It means it is also equal because these two, they're equal. And if EFG is equal to E1 plus H1, we can see that that's the same thing as D3. It means this is equal to angle D3. This is equal to angle D3. And this is what, guys, I said we must prove. If we can prove that this angle D3 that we see and this angle F, which is F1 and F2 are the same, if we can prove that this, which is our EFG, EFH, if we can prove that these two are the same, it means it's a cyclic quad. Exterior angle is equal to what? Opposite interior angle. So this is, we are talking of what? Exterior angle being equal to opposite interior angle. So therefore, that's a cyclic quad that we have. So therefore, this DEFH is a cyclic quad. Is a cyclic quadrilateral. So the reason it is going to be of the exterior angle. So just going to write in short, exterior angle equal to the opposite interior angle. All right. So that's, we have proved that that one is a cyclic quadrilateral. Then also prove that DF bisects angle HFE. That's on 11.3. DF. Where is line DF? This is DF. DF. This line DF. It bisects angle HFE. The angle that we just calculated, HFE, the wall that we were stating there. So if it bisects, what does it mean? If this line DF is a bisector, it means these two angles must be equal. F1 must be equal to F2. That is what it means. F1 must be equal to, so you have to prove that F1 is equal to F2. So how can you prove that F1 is equal to F2? How can you prove that F1 is equal to F2? That is what you need to prove now on this question. Remember the bisector, guys. Bisector, it divides the angle into two equal parts. So if we can prove that these two are equal, guys, we are done. All right, remember before we said angle H1 and F2, they're equal from our tan code. Remember we talked about this before. Angle H1 and F2, we say they're equal from our tan code theorem. Remember that. All right. And we said H1 is related to F1 from where? How can we relate H1, this one, to F1? If we are to consider this, because already there we say these two are equal. Remember we said this is a cyclic quadrilateral. D, this one we proved that DEF, H like this. This is the one that we just proved that it's a what? It's a cyclic quad. So if it is a cyclic quadrilateral, therefore, angle H1, this one, and angle F1 must be equal. Why? They are subtended by the same chord. Chord DE creates angle at H. The same DE is going to create angle at F. Remember, we proved that it's a cyclic quad. So there's a circle there. So it means angle F1 and angle H1, they're also equal. So H1 is equal to angle F1. From the circle that we proved that it's a cyclic quad, now we are using that because we proved it. So these are angles subtended by the same chord, or angles in the what? Angles in the same segment. Angles in the same segment. So if we are saying H1 is equal to F2, the same H1 is equal to F1. What does it mean? Therefore, F1 and F2, they are equal. So therefore, angle F1 is equal to angle F2, which is the one that we wanted to prove. If these F1 and F2 are equal, it means DF is a bisector. So therefore, DF is a bisector, or let's just say bisects. Therefore, DF bisects HFE. To bisect an angle, the two angles must be divided into two. They must be equal. They're being subdivided into two equal parts. All right. Then if K1 is equal to E1, prove that GK is a tangent to the larger circle at K. If we have this K1 equal to E1, all right, where is K1? So the disadvantage is that there'll be a lot of things on this type of a question, and they want you to have something that is very, very meaningful there. All right, let's just try remove some of these things. I just hope guys you're gonna remember what we say they are equal. We say, remember, say these two, they are equal. Before we said H1 and F2, and we said E1 and all right, E1 and H1, remember, say they're equal. All right, no problem. So this is it. Now let's just remove some of these things, guys, so that we can properly see our question. Now we are being told this time that K1 is equal to E1. All right. That's angle K1 is equal to E1. With this information, prove that GK is a tangent to the larger circle. GK from G, this one, GK is a tangent to the larger circle. This is what you're supposed to prove. GK is a tangent to the larger circle. How can we prove that? If we are given that, because this is what you're given now, that K1, where is K? This is where we have our K, and this is K1. They say this angle at K, this one, K1, and this angle at E, they are equal, E1. These two, they are equal. So how is it going to help us if they are equal? All right, let's try and analyze our question, guys, to prove that it's a tangent. If it is a tangent, then it must give us the properties of a tangent. If truly it's a tangent, it must show us that the angle between a tangent, which is this K2, angle between a tangent and a chord, which is the chord KF, must give us angle E2. So we must prove that angle K2 and this angle E2, they are equal. This is what you need. If you can prove that angle K2 is equal to angle E2. If we can just prove this, guys, we are done. How can we prove that these two angles are equal from what we are given? So our focus must be on K2. Our focus must be on K2. All right. No problem. Let's see where we have K1 and K2. All right. K1 and K2, these are the two angles that we see here. And previously, we are told that K1 is equal to E1. This is what we are given before. So the sum of these two, where can they be related, guys? Where we have E1 and E2 at the same time. E1 is there, E2 is there. All right. Let's consider from H there, because we have from this circle there, we have got H3 and H4. Remember, this is representing the exterior angle of a cyclic quad. If you take this H4, right, as your exterior angle, it is supposed to be equal to what? Using this whole line, it must be equal to this angle. But if you take H4 and H3 as this angle here, considering as an angle this one, we are going to consider, say, this is the chord that we have, this one. This is the chord that we have. And this is our tangent. So the whole of this angle must add up or must be equal to this angle that is being created at K, which is K1 and K2. All right. So there, I'm just going to try to explain that you understand this type of equation. It needs, I don't know, like how many separate diagrams that we can use. But anyways, let's see. So if we use H4 and H3, same as K1 and K2. But remember, I told about K1 and E1. So meaning to say it is simply equal to E1 plus E2. Remember, this is a circle. Remember, we proved that this is a circle, guys. Yeah, it's a circle. So you can equate to that one. So meaning to say the whole of angle E1, let's take it from there, H3, H4, the whole of it. H3, we add it together, which H4. It is going to be E1 and E2 combined together. Remember, we proved that there's a circle here passing here like this. There's a circle passing. So also we can use that concept to say this will be the exterior angle and this will be the opposite interior angle. But it is the same thing that we are relating. So it is the same angle related to two parts here also. To be equated to E1 plus E2, it is because we proved that DEFH is a cyclic quad. So this gives us the condition of what? The exterior angle of a cyclic quad. So we're going to talk it from what? The exterior angle of a cyclic quad, which will be equal to the opposite interior. Right? But the same H3, H4 that you're talking here, considering this one, considering inside, it is the same that we're saying here, it is the same. H3, the same H3 plus H4 is equal to the sum of K1 and K2. K1 plus K2. It's also equal to that part. Which concept is this? Now we are talking of the tan chord from this smaller circle that we have there. It is a tan chord. Angle between a tangent and a chord will be equal to the angle in the alternate segment. So for these two to be equal, it's because of a tan chord from the smaller circle. Guys, remember what is it that you need to prove? Like I said before, we need to prove that K2 and E2, they're equal. From these two that we are seeing, it simply tells us also that these two are equal because it's the same, this one. So these two are also equal. So from these guys, we can simply see the sum of E1 plus E2 is equal to what? K1 plus K2. And from there, we are told that K1 is equal. This one we are already given, that is the same. So if K1 is equal to E1, therefore, what does it mean? It simply tells us that E2 is equal to K2. So therefore, angle E2 is equal to K2, which is the one that we need to prove here. K2 is equal to E2. If we can prove that these two, if we can just prove these guys, that angle E2, this one, and this angle K2 are the same. That's the theorem of it. That's the tangent angle between what? A tangent and a chord is equal to the angle in the opposite segment. So this is the converse of the tan chord. Instead of us being using the tan chord, we are now working from the vice versa, tan chord. So therefore, we are saying KF, truly KF. Sorry, this one. Yeah, this part of our KF. Truly it's a tangent. Is a tangent, as we had there. All right. Not KF, but this one, guys, GK. This one, G to K. This one, this one. From G to K, this one. So therefore, we can prove that GK is a tangent. So that is considering the what? The converse tan chord theorem there. So this one will be the converse tan chord theorem. Tan chord theorem. So you just need to be very, very careful in your presentations, how the questions are given, especially the last question, guys. And last question, you just have to figure out. Mostly try to figure out because it takes you a lot of time, but it's important that you try to attempt it. And lucky enough is the last question. So even if it's going to take you a lot of time in exam, but you know that is the last question. So you have already acquired a lot of marks from the previous this is 15. So just subtract like 150 minus 15. Let's say you fail to attempt it. You are marking yourself out of 135. But try by all means to attempt the last question there. It's not always that it's going to be having those difficulties. I understand that as you are working because you need like separate sketch because the sketch that you use, you have to erase, you have to erase that because there are so many constructions that you need to like present there. So guys, do revise as many questions as we can in light till we meet again.